This conference will now be recorded.
Right. So the service, the service called Virtual Private Cloud, VPC. Right. So in our AWS, whatever the services we are using so far, those will be belongs to a region. Under the region, they are going to a provide a subnet for us. Let me show you the so that subnet in the sense cloud. So they are going to provide a separate cloud, right? So when we are going to discuss about the cloud can be divided into public cloud, private cloud, hybrid cloud. Public cloud is nothing but free. Free in the sense anyone can share the cloud. The space, whatever space we are taking in the public space, that can be shared with other persons also. Right? Private cloud. So private cloud is nothing but right. So I don't want to share my space. Right? I'm having sensitive data which I don't want to share it to anyone. Share to means not the data space. What are the space we are going to take? So in that case, what we can do, we can take entire private space so that the space will be belongs to us. Now, if I take the public, it is cheaper, but the problem is security. If I take the private, it is costlier, but I will be getting the security. But again, I have the budget constraints, so I cannot place all my services into the private cloud because there are certain services are there which has to open for the public. And so there, what they came up here is hybrid clouds. Hybrid clouds are nothing but you will be having a public cloud and you will be having a private cloud. Combination of public and private cloud. Now here, as of now, whatever the services we are using, suppose let me take the EC2 service. This EC2 service, we have launched instances. With the help of EC2 service, we have launched the EC2 instances. So now here, so suppose this is an instance. If I go to the properties of the instance, not showing here. Let me go to the description section. So here, this is the one. VPC ID. Every service will be attached to the VPC. Right. So now the VPC is nothing but the cloud. Right. So the space, what is the space? The cloud is provided. So now this is the VPC virtual private cloud from the AWS side. Right. So a cloud, a public cloud is going to provide to us if you are not going to take any cloud from your end. Any space in the sense, cloud in the sense, any space if you are not going to take from your end. So then by default it will be connected. Your services will be connected to the default VPC ID. This is the one which the AWS is going to provide to us. Now I want to have my own cloud, my own private cloud, so that my services, everything I want to launch in that cloud, I want to make them secure. I want to make them secure, so that the other folks cannot utilize the same VPC. This is what my requirement. So usually, in our organizations, we are going to create our own clouds actually, not to the public. We are not going to go with the public clouds. Right. So now here, if you want to create a cloud, virtual private cloud, so then there are certain services we need to use. Services are the components. So now if I go to this diagram, right. So now this is like how the VPC will be looks like, our own VPCs. Right. So usually when it comes to the project level, right, when I'm going to set up any servers, right, basically our applications are going to run on the servers. When you are going to set up the servers has to be placed on the public cloud or the servers has to be placed on the private cloud, right? And what kind of security layers we are going to apply. then how the people are going to reach your servers. Everything you need to take care when you are going to take your own cloud. If you are going to go with the public cloud, then you don't require to take care of all the stuff. They will take care of everything. That's enough here. If I want to create my own cloud, then this outer line is the my cloud actually. Then once the space, right, once the space got created, inside the space we are going to launch our services. Right. So now here, as I said, you can have the public servers or you can have the private servers. Whatever the application deployed on the server, right? So now the application has to be reached to everyone. Anyone can reach your application. Those we are going to call as a web servers. Now these web servers you can place on the public side, on the public front, so that anyone can reach your application. But whatever the data we are going to store, right? So the data should not be public, right? Because you are going to store the sensitive data like customers data on the database. So that should not be stored. That's in the sense that should not be placed on the public. So that should be placed in a private area so that no one can reach your servers. The servers are nothing but now the DB servers, like that. So like that, what you are going to do when you are going to create a virtual private cloud, a space, once the space got created, then inside the space you are going to define the blocks. Now the blocks are nothing but one block I'm going to make it as a public, one block I'm going to make it as a private, so that all the public servers, the internet facing. So I'm going to place on the public block, and whatever the sensitive or the databases or the APIs, backend APIs, those I'm going to place in the private. So those should not be open for no one. So now these blocks we are going to call as a subnets. Right. So now these blocks we are going to call as subnets. Now once the VPC is created, now we are going to divide the VPC into subnets. Now the subnets are nothing but you will be having a public subnet and you will be having the private subnet. Now the purpose of the public is, as we discussed, for the web servers, and the purpose of the private will be to store your DBs. Yeah. So then once the VPC then subnets are created, right, then we are going to place what? We are going to place the routing tables. Routing, right? So now because whatever the requests are coming to your VPC, so now you need to decide, you need to or you need to tell your VPC that take this request to the public servers, take this request to the private servers, like that. Like that, we require to route the traffic. So now who is going to take care of the routing here? Route tables, this area, routers. So now these routers will be having the route tables. These route tables, in the route tables we are going to define, right? So the traffic where should be routed. That usually the traffic should be routed to the public subnets, because the public subnets will be having the web servers. Right? So that access we are going to provide to everyone, not to the private, like that. So right. So now here the route tables are going to define, or the route tables are going to take care of the traffic routing. Right? Once the customers are trying to connect the application, then the request has to be routed to so and so subnets. So then here, once the route tables are defined, then here you can see the connectivity gateway, right? So because VPC, virtual private cloud, your own cloud. So when I'm going to take my own cloud, if I'm not open my space to anyone, right? So then how the people will reach my application? Right. So whatever the servers I have launched in my cloud, if I've not opened those servers for the public, then how they are going to reach? Right. So that is the reason the VPC is required internet gateways, so that the internet, via the internet gateway, our request is going to travel to our servers via the route tables. Right. So now if I don't attach the internet gateway, now no one can reach my servers. It is a complete private cloud. Right. So now here, but my application, right? Now my application should be open to everyone. So right. So now anyone can reach my application. If the people are trying to reach the application means your VPC should open the network so that the request can be received. So if the network has to be open in the sense, you have to have the internet gateway has to be attached, right? So that you can connect to the internet. So now this is what the internet gateway, right? So then here the last one is in between, right? So now here you can understand like traffic will come to the internet gateway. From the internet gateway, it will go to the router. Then from the router, the route tables are going to take care of which request it is and what where it has to be routed. So then from the route table, it will go to the network ACLs. Network ACLs are nothing but network access control list. Right? So now these network ACLs, what they will do, they are going to filter the data. Data in the sense here, filter the requests. What are the requests are coming through the internet gateway and via the route tables, these requests will be filtered out here in the network ACL. Right. So now once the requests are filtered out, then the request will go to the corresponding subnets, public subnet, or if it is coming through here, then it is a private subnet. Then inside the public subnet or private subnet, you are going to have your servers. Right. So now this is the complete setup of the VPC. Now if you are trying to set up a VPC on a project, these are all the components we need to take care. Internet gateway, router, route tables, NACL, SIC, and public subnet, private subnet, then launching the servers. Right. So now the last part is here. It is an option for us. So now here VPN. Right. I think you guys know VPN, right? So when you want to connect the secure servers, right? So the client server, then we will go with the VPN. So those VPN connectivity, nothing but like this is for us actually, not for everyone. This is only for the internal employees. Yeah. So to connect to our servers. Now the VPN, like the channel, will open a channel. So through the channel, we are going to reach our server. Right. So now here, right? So let's try to set up the same infra and try to understand. We'll try to understand all the components one by one. Right. So that will be right. So now here these are all already taken care by the AWS when you are using the AWS provided VPC. Right. So there is no concept of private and something. They will be always public for the VPC of default VPC of AWS. So now if you are going to create your own VPC, then this concept will come to the picture. Right. So now let's see. So I'm going to create a VPC now. Go to the services and search for VPC. Right. We can observe here VPC is one there, subnets are there, route tables, right? Internet gateways. We have discussed about this thing. NAT gateway we will discuss about. NACL security group, VPC peering, I will let you know. Right. So now the NACL security group, these are all the components of the VPC. Right, whatever we are seeing right now here, those are all belongs to the default, the AWS provided one. Right. So now here I am going to create my own VPC. So select your VPCs. Then this is the default is available. Then I'm going to click on create VPC. Here I'm going to use my VPC some name. Then the IPCADR block. So IPCADR block is something like this. So means whatever the servers, like basically what we are going to do, finally we are going to launch some instances inside the VPC. Right. So whatever the servers you are going to launch, now the servers requires the IP, right? The server is going to attach to the IP. So now this IPs we are going to define here. We are going to define here. So when the new server is going to launch inside my VPC, then the VPC, sorry, the instance IP should be start with 10.10.6, 10.0.1, 10.0.2, something like that. Yes. So now here we are going to allocate the IPs to our VPC, what are the VPC are going to create. So we are going to allocate while creating the VPC here. Right. So now here the slash 16. The slash 16 is nothing but give me a second. Yeah. So now here this shared block is a networking concept, is a very big story. So let me try to give some kind of overview, right? Because I am also not a network admin here. Right. So here, so the IPs I am going to tell that I am going to take the IPs from the 10 series, 10.0 series. So now here, how many IPs you require here? Okay, fine. So we are going to allocate the IPs with the series. Like now, usually IPs are the 4 block one, right? One, two, three, four. So now here I am going to ask the AWS folks that I want to have the IPs from 10.0.01, 10.0.0.1, 2, 3, so on. Fine. They are going to allocate the IPs to me. But how many IPs you require actually? So that's what the slash. The slash, the representation is how many IPs you are going to take. Right. So here there is some what it is called. We have a list actually. So slash 16, how many you are going to get? Slash 8, how many you are going to get? We have something like we have class A, class B, class C. Network type will be there. Out of class A, class B, class C, they are going to attach different kinds of IPs for us. So let me show you the list actually. Right. So now here, yes. So this is the CIDR table actually, right? So how many IPs I'm looking for? So those we are going to mention by giving this example. You can go to this documentation. Yes, so here. So now here I am giving /16. So now this is the CIDR block actually. If this is a CIDR block, then here if I give /16, right? So total number of subnets I am getting here is 254, and the number of hosts 65,000. Okay. So now the total host 65,000 hosts you can launch. Right. So likewise, this is the notation actually. So now if I give /10, now total subnets I'm going to get, and these are the number. Likewise, if I go increase 30, 30 means you are going to get, you can launch only 2 servers. Yeah. So max will be 32. Max will be 32. So 32 nothing but only one server you are going to launch, one IP you are going to allow. Right. So likewise, this is the notation actually. Right. So now here you can see here the filling, like the four IP, the four block of IP. IP will be having four blocks. So now 255, 255, 255, 255. When I give 30, right? So now sorry, 252. When I give 30, at the last one is 252 means you can get the IP 255, 255, 255, then 252 or 253 or 253 or 254. Like that, you are going to get only two IPs here. So now here if I go to 29, then it becomes the 248 means I can have 6 servers. If I give /29, then I can get the 6 servers. The last one will be allocated for us. 248 to the max will be the 255. 248 to 255. Right. So then out of 7, one they are going to take for the general purpose. 6 will be allocated to us. Like that 28. If I give 27, like that. So now here if I give 24, right? So then I am going to get 254. 254 hosts I can get means the last one is allocated to one, allocated to us, 0 to 254. The servers you can launch, they will be 252, 252, then finally you can launch 0 to 254. Your server IP will be something like that. So like that, if I go on here, then you can see here now two blocks are allocated to us when if I give 60. So means these two are already occupied, and these two will be given to us. These will be 1 to 255, and after that 1 to 255 is going to fill up here. So like that. So like that, we are going to take the IPs with the help of this CADL block. So how many IPs are required? So then once I define here, based on that, your subnets are going to create. The blocks are going to create like this. Right. So now here again, each block will be having their own definition. So you cannot take this one for your IPs. Actually, this is for some routing. Like the different networking concepts are there. But for us, like how to define the CID block, how many IPs are required for us. So right, so for that I'm going to to practice it, I'm going to take the 16 means the two last two are allocated to us means I can create 65,000 servers inside my VPC. More than 65,000 plus servers. I can launch in my VPC. That's what here when I give 16. Okay. So now here let me go to the VPC. So then the block I have mentioned as 10.0 means so these two are for me and these two for the maintenance purpose. The other purpose then 65,000 will be allocated to me. Then right. So IPv6. If you require the IPv6 means 6 series IP. If you are looking for 6 series IP, then you can choose the Amazon, or if you have your own, then you can take it. Otherwise, go with the IPv4. Right. So if you want to have a dedicated hardware, the tenancy dedicated hardware if you are looking for, you can go with the tenancy dedicated. Right. So I don't want to have any kind of dedication because my VPC belongs to me. I'm not going to do any for us. So tags, you can leave the tags. So by default, tag name is a my VPC. Fine, you can create VPC. Now, if I go to my VPCs, apart from the default, we are going to see our own VPC with the name my VPC. And this is the VPC ID they have provided. And this is the my IP's range, IP name, and this is my IPs I'm looking for actually. Right. So now here, what will happen in the background? When I created VPC, in the background, it is going to create a subnet for me. Go to the subnet. Oh, no. It is not these they are the default one only. So subnet is not created. So so go to the route table. Yes. So not the subnet. One route table is going to create. So this is the VPC ID. Just now I created. Okay. So this is the route table. And by default, this is the default behavior. When you created VPC in the background, one route table will be created automatically. Likewise, if I go to the security groups, so here also one security group also will be created. See here, this is the VPC ID. These are all the VPCs are the default, and this is the one which we have created. So this security group is created for this VPC default, one default security. Right? So we are not created these two. Automatically they are created once the VPC is launched. Route tables and security group, and I think one more component also we will go to launch. Network ACLs. I go to the network ACLs. Perfect. Right. So network ACL also one network ACL also will be created for our VPC. Okay. So now here, once the VPC is created in the background, one security group, default security group for the VPC, one NACL, and one route table. One route tables are going to create. So now based that whatever the requirement we are going to have, based on the requirement, we are going to launch more subnets or not the subnets, route tables. You want to have extra route tables, you can create the extra route tables. If you want to have the extra you want to modify the security group, you can modify it. Right. So whatever you want to do, you can do the operations. Right, based on the requirement. But these are the default setup you are going to receive once the VPC is created. Right. So now here let me go to our document. Then we'll follow the rest of the steps. So default will be created. A new route table is created. We observe that a new NACL is created. We observe that, and the security group also will be created. We observe that. So now here I am going to create I'm going to create the subnets, right? So now VPC a space I have received. I got the space. Now inside the space, I want to launch the servers. So now your servers can be a private servers, your servers can be public servers. So now you should not launch all the servers into same space, right? Because the private and public, if you launch both public and private, there is a chance of hacking, right? So that is the reason now this VPC is going to divide into blocks. Now the blocks are nothing but private and public. Yeah. So now these blocks we are going to call as a subnet. So I'm going to create a subnet now. Right. The subnet name we are going to provide as some name we can provide. So 10.0.1.0, like this is the series I'm going to launch. So for that I have given something. So now here let me go to the VPC and go to the subnet section. So if I go to the subnets, as of now we can see three subnets are there. Those are belongs to the default VPC. So now we are going to create our own subnet. Right. Name 10.0.1.1.0. I am going to launch this subnet on US East 2A. Right, I am on the US East 2 region. Now in the region I have three subnets 2A, 2B, 2C. So now this subnet I am going to launch in this region. So for easy identification, I am giving this we are giving this name actually. Okay. So now here VPC, right? This subnet and right this subnet has to be launched inside a VPC. Which VPC are going to take? Right, our own VPC. Right. So availability zone, where you are going to launch. I want to launch in the 2A. This subnet inside this region. Inside this region, I'm going to launch in the availability zone 2A. Right. So now here, this is the complete CADR block. Means 65,000 IPs you are going to receive for the VPC. Right. So now this is the VPC right now I'm having, and this VPC will is a capacity of we can launch 65,000 IPs. So now here, right? So now 64,000 IPs in the sense 64,000 missions you can launch. Right. So but here as we discussed, we will be having the public and private servers. So now further what I'm going to do, we are going to divide this subnet into the blocks. So now this block I'm going to call as a public, and this block I'm going to call as a private. So that since two servers should be placed here, whatever the servers I'm going to have, the DBs or the backend APIs will be launched here so that no one can reach. But when there are application web servers, I'm going to launch it here so that people can reach. Right, so now here I have divided these VPs into two blocks, private and public. So now for the public, how many IPs you want to allocate and what is the series? Right, in the same way, for the private, how many IPs you are going to allocate? What is the series? Right? Because overall you can launch 65,000, but with this part is divided into blocks. So now here, how many IPs you want to launch? How many IPs you are going to take on the private? How many IPs you are going to take on the public? And what is the series? The right, so 10.0.0 or you want to go with the 10.0.0.0, or you want to go with 10.0.1.0 or 10.0.20.0, like that. The IP range. That the IP range has to be defined, and how many IPs required, that has to be defined. That's what here subnet CADR block. Right, this is the complete IP series. Out of that, how many IPs you require and what is the series you are looking for. Right. So let's go to the diagram. Here, see here, we are taking one series here. So now here, whatever the IPs are going to start with 10.0.1.1, 1.2, 1.3, like that, those are nothing but my one of the subnet. It can be a private and public, will decide. So one of the subnet, these IPs are. So now here, 10.0.1.0 by 24 now I have given. Now when I give 24, so usually how we are going to calculate? So the max is the 32. Max is the 32. So now how we are going to calculate it? 2 power 32 minus this 24. Right. So 32 minus 24, 8. Now you need to calculate 2 power 8. Now those many IPs you are going to get. Usually the calculation will be, we are going to do like that. So now if I go to the chart, if I give 24, like I can get 255 IPs, 254 IPs. That means the last one, the last fourth one is allocated to us. So now here, when I go to our VPC, then this is nothing but we are going to get the IPs 10.0.1.02, 10.0.1.254. So whatever the IPs with the 1.1, 1.2, 1.3, 1.4, 1.5 until 1.24 all belongs to this particular supply. Later we are going to decide whether it is a private or public. We are going to decide. As of now, all are private. When it is going to become a public, when it's going to become a public, when you attach the internet gateway, then it is going to become a public. Until unless all are private. As of now, we are not attached any kind of internet gateway. Right? So just we are trying to. We have created a VPC. Under the VPC, one subnet I have created with the series. So now close. Then this step is done. Then here, right? So usually the total 255 IPs means 0 to 255 means 256 IPs actually. It will start 0 and it will end with the 255. So 0 to 255 means 256 IPs. Out of 256 IPs, right? So they are going to allocate only 251 IPs. The rest of the 5 IPs are for their maintenance purpose. Right. So now total 256 IPs are there. Out of 256 IPs, only 251 IPs are going to allocate to us. The rest of the 5 will be for the internal purpose. So why, what, what kind of internal purpose they are going to use here? Right. So now here, if it start your IP series starts with the 10.0.0, then 0, the first one will be allocated to the network address. The 10.0.1 will be allocated for the reserved by AWS for the VPC router. For the VPC router, it will be reserved. Then 2, reserved APC address for the DNS server. So for the DNS server, they are going to reserve this 2. Right. So then the third, reserved by future use. Right. In future, sometime if they require a VPC, a IP from the VPC, right? So by that time, if all the IPs are allocated to some other thing, then they cannot take it. So there is a reason for the future purpose. One IP will be spared by AWS. Then the last, now first 3 will be for network address, VPC router, and the DNS. And the fourth one is the future purpose. Then the last 55 is the network broadcast address. So for this sake, they are going to keep 5 IPs with them. These 5 IPs, 1 to 3, then last one. Right. So now here I am going to create one more subnet because I need a private subnet and a public subnet. As of now, I have created one subnet that is not the private and public, that is the private only as of now. Again, I'm going to create one more subnet. Now the subnet name I'm going to give it as 2 series. The subnet is going to start with the 2 series 10.0.2. 10.0.20. Right. So now here this one I'm going to launch into the zone B, into the some other zone, because right high availability should be there. So now here let me go to the VPC. Right. So now you can observe here before going to create the subnet, you can observe here the allocated IP is 251. Right, as we discussed, right, out of 256 we are going to get 251 IPs. Then create subnet. I'm going to create one more subnet, and here I'm going to use name 10.0.2.0 US East 2B. For my understanding, that's it. You can do any name. Now here 10.0 point. Now I want to start this series with the 2 by 24. Right. So one is for the US East 1A, 2A, sorry, and the second one is for the 2B. And for the 2B, I'm going to launch 251 servers. The 251 servers are going to attach with the IP 10.0.2.0 to 2.254. Create it. Likewise, here now you can observe here the chart. So now this is the CID block I have taken 16, right? So now when I taken the 16 series, the IP is nothing but I can have total 65,536 missions. I can launch 65,534 missions here. So now here, how many subnets you can create? You can create 254 subnets. That's what the count here is. Right? So likewise, you can create that how we have created. Right now, I have created two. Likewise, you can create max 254 subnets in that VPC. If I take the VPC, CAD block is a /16. Likewise. So now go to close, click on the close. Now here you can see there are two subnets. Those two subnets are attached with the 251 IPs. The one is 1.0 and the second one is 2.0. So now let's go to our diagram again. Okay, perfect. So now this is the right now we are on this page actually. Right now you can observe VPC is there. Right, so VPC is created with /16. Now under the VPC, I have launched we have launched two subnets with the 1.0 with the 2.0. Now these are the one subnet and this is the one subnet inside my VPC. Now one router, one security group, one network ACL. These are all created as a default. These came with the default once we have created the VPC. Correct. So now as of now we are not touching this one. These are the default one which we got with the VPC. We have created only these two subnets. Now we can observe here these two are the private only as of now because no internet gateway is connected. No public facing. When you don't have the public facing, all are private only. Right. So now both are the private only as of now. Now the next step. Internet gateway I'm going to check. So now the internet gateway is nothing but we are opening the route for the public so that people can reach your VPC. Then people can reach your servers inside the VPC. Right. So now create internet gateway and attach the internet gateway to the VPC. Which VPC? Your VPC. So now I'm opening the public facing. So I will go to the internet gateway section. Yes, here. Go to the internet gateway and this is the one we are saying for the VPC called default. Right? As I said, they will take care everything when you take the default VPC. Now we are going to have your own VPC means you have to take care everything. Right? So now here I will go to the create internet gateway. Then the gateway name, my IZW, internet gateway, something. So now here tag, leave it, create. Once the internet gateway is connected, that once the internet gateway is created, sorry, not the content, created, then attach this gateway to what? To our VPC. Right. So you can see here, attach to VPC or go to the internet gateways again. Now we are going to see two entries. Select the one. This is the one I have created. Then actions and attach to VPC. Simple. Say here, go to the VPC section and select your VPC, my VPC. That's it. Attach. Now my VPC is connected to internet so that people can reach my servers which are launched inside my VPC. Right. So now here the thing is once you open the attached internet gateway, then you people can access your servers with the help of gateway. Now you need to define the traffic. You need to route the traffic to what? To where? To the subnets. So now you need to create the subnets. The subnets has to be divided into private and public. Now already we have created the subnets. Now I need to make them as a private and public, and I need to route the traffic from the internet gateway to the particular subnets. That's what I need to do. Right. So let me go here. Now, right. So now here, once the internet gateway is attached to VPC, now what I'm trying to do here is I am trying to associate subnet to the route table. The linking. We are trying to make the linking between the route table to subnet so that the traffic will travel to the route table to your subnets. What are the traffic we are going to receive from the internet gateway? Right. So now the linking we are going to enable. So as of now, if you observe here in the previous diagram, there we can see only one route table from the router, only one route, because this is the default we receive. So now, but here we have two subnets. Now, if people are trying to connect to the private, now authorized people, not by everyone, authorized people, if they want to connect to the subnets of the private, then they have to have their own route table. Because if I have only one route table, now the traffic will travel to the internet gateway and to the router, to the route table, to the subnet. Right. So if I have the only one route table, then I can give the route table to the public so that it can reach the public. But when it comes to the private, I cannot travel to the public route table. So for that, we are going to have one more route table. Then we are going to connect the route table to the subnet. Okay. So now here for that, we are going to create one more route table. We have one route table as a default. Then we are going to create one more route table. Go to the VPC. Now here you can see route table section. Click on the route table. This is the default which you have received. So I'm going to create one more route table. Right. So here, just give a name and select the VPC, then save it, create it. My internet route table, nothing but the public. I'm going to call this as a public route table. Then VPC. This is the VPC I have created. Once this is created, then here add the internet gateway to the router because I'm going to call this internet route table means public route table, right? So now this route table I need to connect to the internet so that the traffic will come to the internet gateway will go to this particular route table, right? So now to attach the internet gateway to the route table, right? So go to the route and add the internet gateway. So now here let me go to our VPC, close, and this is the internet route table, right? So this is the this is the one which right now I created, and this is the one by default I got it. So now this is the one I'm going to select. Then under the properties, you can see here subnets association. So that is not the subnets, routes association, routes. Routes here. So as of now, 10.0.6 means whole complete VPC. Now what I'm going to do, I am going to open for everyone, right? Because anyone can reach my server of the public subnet, not to restrict to anyone. So open for everyone. Then here attach the internet gateway. Right. So here click on edit routes, click on add route. As of now, only the VPC folks can reach the CAD block. So now I'm going to give the access to everyone. 10.0.0.0 means any IP. Then target internet gateway. This one. That's it. Right. So now everyone in the sense anyone throughout the world, anyone can connect my VPC internet gateway. Can connect my VPC internet gateway. So now once the VPC internet gateway they are connected, now which subnet is belongs to that subnet is going to travel to the subnet. Now before the subnet traveling, there is a route table. Right. So from the internet gateway, it will go to the route table here. Which route table now? So whatever the route table I have used it. Right. So this route table I have linked with the internet gateway so that the traffic will travel to the internet gateway to this route table. Right. So now this route table is going to associate with the subnet so that the traffic from the internet gateway to the route table run from the route to the subnets. That's the link we need to establish. Right. So now here, let me go to the diagram again. Right. This is the part is completed. It will give the both access of IPv4 and IPv6. Now subnet association, like as we discussed, right? So now here internet gateway to the route table to the subnet. Now go to the subnet association, and right now we have the two subnets, one series and two series. Out of one, both are private only as of now. Now I'm going to make one subnet as a public by associating the subnet here. Right. So let me associate the subnet to my route table. Click on. Right. So now here this part is completed routing. Now associating the subnet. Click on the subnet, edit subnet association. Then here you can see our two subnets 1.0 and 2.0. Right, I'm going to take the 1.0. Anyone who can take it here. So let me take the 1.0. Select, then save. That's it. So now the linking between the internet gateway and route table and our subnets, that all three are linked one and each other. So now the linking means the traffic. So now the people who are trying to connect to the internet gateway, now the traffic will go to the internet route table. What are the route table I have created? From the internet route table, it will travel to the subnet. What is the subnet? 10.0.1.0 subnet. That's it. That will be a public subnet. Now, this subnet 10.0.1.0 becomes a public subnet. Why? The internet gateway is attached to this particular subnet. Now, is the internet gateway directly attached? No. The internet gateway is attached to the route table. The route table is attached to the subnet. Likewise. Right. So this part is done now. So let me. Yeah, this is done. Right. So whatever the servers we are going to launch, correct? Whatever the servers we are going to launch inside the public subnet, those servers require the IPs so that you can connect to the servers. For the private, you should not have the IPs. You should not connect. Right. So now here you have to assign public IP settings so that whatever the servers are going to launch inside the public subnet, the servers are going to attach with the public IPs. Okay. So right. So now let me go and modify the settings to access servers. Change the setting of auto assign IP. Right. So now here go to the subnet. Go to the subnets. Now right, which subnet is required? The settings. Public subnet, right? Public subnet is required the settings. So now select the public subnet. Then actions, modify auto assign IP settings. Then enable auto assign public IP. This is something a new feature they will add. Enable auto assign customer owned IP. Okay, I don't have any my IPs. Now this is the one. Auto assign, save it. Perfect. Right. So now IPs are attached. Sorry, we have modified the setting of auto assign IP so that the servers will get the public IPs once the servers are launched in the public subnet. Now create two instances using our VPC. Right. So now here create a security group for the public one to allow the traffic, and choose the default security for the private one not to allow the traffic. And public subnet will have the IP because the setting we have allocated assign. Now try to test it. Right. This is the current state. We have the internet gateway, the router is available, Now I have created a public route table, internet route table, and this is the default which we got. Now this internet route table, that as of we are not discussing in the net NACL, we'll discuss later. This public route table is attached to the internet gateway, then it connect to the public subnet. So now here I am trying to launch two instances. One is on the public, one is on the private, and try to connect these servers. Let's how this VPC is going to work. Will come. Okay. So now here I am going to create two servers under the two subnets. Give me a second, guys. Okay. So now here I am going to create the instances. Go to the launch instance and create the instance here. Select, fine, go with the default configure here. Click on the configure. Now I am not going to go with the default one. So select the VPC and choose your VPC. Now here you can see subnets. Under this VPC, how many subnets are there? Two subnets, 1.0 and 2.0. 1.0 and 2.0. 2A and 2B. Two different zones. Select the subnet. Right. So now here, rest of the things I am going to ignore. Right. We have discussed these things. So I'm not going to touch the rest of the options. The only the thing is VPC and the subnet. Review and launch, and the key launch. Perfect. Now view instances. I'm going to give as public, just for identification server. I'm going to launch a new instance here. Select and let's go to the configuration now. Choosing my own VPC. Now this subnet should be private 2.0. You can see 251 IPs are going to allocate. Event launch, acknowledge. So this is my private server. Right. So now here this private server, I'm checking for the subnet. Yes, this is the one actually. So the subnet. So this private server is connected to the subnet 10.0.20. Right? Now we know 10.0.10 is a subnet. It is attached to the route table. The route table is connected to the internet gateway. So now the 10.0.1.0 become as a public subnet. So now 10.0.2.0 is not connected to any route table and it is not connected to any internet gateway. So it is a default one. It is a private route table. I mean to say private subnet. Right? So now here we can observe here this server is connected to 10.0.2.0 means is a private. And now I'm going to select the public one. Now you can see here it is going to connect to the subnet 10.0.10. Perfect. Right. So again, the IPs. Right. We have mentioned I need this IP range and this IP range. For the private, this IP range I am going to look for, and the public, this is the IP range I am looking for. So now let's go to the IP section here. If I go to the public, right, you can see the public IP. Right. So why the public IP came? Because I have given the option. I need the public IP so that I can connect to the servers. What are the servers I am going to launch? So this public IP is going to given by whom? The AWS folks. Then whatever the our series, right? I have mentioned this is the series I want to have to my public, and this is the series I want to have for the private. Those are the private IPs. Right. So let's go to the private IP here and see. Perfect. Right. So now 10.0.1. Then 0 to 254 IPs are going to allocate to us with the CAD block, whatever I mentioned. So now 158 is allocated to me, 10.0.1.1 series. So likewise, if I go to the private, now the private will not be having any public IP, cannot connect to the servers directly. No, not possible. It is a private sensitive data, sensitive servers. Now here you can see the private IP to 10.0.2. That's what I have given, right? 10.0.2.0 slash 24. Some 45 is allocated. Perfect. So right, both I got the same. So now here, let's connect to the server. So here, the security group. Open the security group ports. Launch wizard 8. And here I'm going to open inbound route so that I can do any kind of operations. All traffic safe. Save. So now here, go to the dashboard. Let me open the private security group as well. This is the private server. So for the private also, I'm trying to open all the ports. But usually, based on the requirement, we are going to open the particular port. So not like we are not never ever we are going to open all traffic. Now, go to the instances, choose the public, select the mission, or go to the connect, and this is the connectivity string. Then go to the git bash and try to run it. Yes, connected. Right, because it is open public server. So right, it got the public IP. With the public IP, if I have the key, I can connect it. So now try to run the operations. Right, so here m update. Right, when I give m update, what will happen? It will try to go to the community via the internet. Right, by using the internet, it will go to the community. Then it will bring the updates. What are the updates are having here? It will bring the updates and it will install it. Right. So now here what is required? Internet connectivity is required. When you're trying to run the update, it will try to connect to the community. So there you require the internet connectivity. So right, so this public server is connected to the internet gateway with the help of the route table, public route table. Right. So now it will allow me when I run m update. See, so no packages are there means you don't require to do any update, already is updated. Let me try to install anything app. Sorry, not the app, right? Yeah, install git or anything you can run here.
Maybe just try and ping.
Ping. Let me ping anyway. Yes, ping. Correct. Ping can be used. Right? Ping
Yeah, ping
Google
if you
dot
can. Yeah,
uh,
yeah.
Google.com. Right. Right. You can see the internet connected. Right. The connectivity is there. So now here, because it's a public. So now here we'll go to the private one and see how the private one will be looks like and how I'm going to connect it. So now here, if first thing will be if I go to the private server, I don't have the public IP to connect it. The first part. If I don't have the public IP, cannot connect it. So then how I am going to connect my private servers? Right? We are going to use the private IP to connect the servers. Now straight away you cannot use the private IP by using the putty or git bash to connect it. Now to connect the private servers, we are going to use the help of the public servers. We'll go to the public server. From the public server, we'll be use the SSH mechanism to connect the private servers. Okay. So now here, let me open the document. Log into the public server. Fine. This is the what. I'm going to use SSH. Now SSH. Then right. So the username and followed with the private IP. Then followed by our key. So now here, let me go to the public server. SSH. Right. So then followed by the EC2-user at the rate, and the private IP is what? This is the one, and hyphen I key is required. Now here I don't have the key. Right? If I try to use, it will go to throw an error because the key is not there. So now here, what I'm going to do, first I'm going to bring the key into the server. Yeah. So right now the key is in my laptop. The key. So now I'm going to bring the key into my public server. So now we know how to connect, how to transfer the data between the Windows to Linux, WinRCP. I will go and use the WinRCP. With the help of WinRCP, I'm going to connect to my public server first. So let me take the public server and take the public IP. Provide the IP, then EC2-user. So then advanced, right? So authentication, right? We know everything here, how to do that. So then not the PPK, right? So PPK is for the putty. So now we require the PEM file, Shankar, right? So here it is looking for the PPK. I am going to change it to all files. Then I am going to select the PEM now. Somewhere it should be there. Yes, this is the one. Sorry, guys. Sorry, guys, I'm confusing actually. Right? So this is to copy the key to connect the private, but here I am trying to use the WinRCP, right? For that, I require the PPK only, not the PEM. So to connect the WinRCP, sorry, I confused actually. I require the PPK. Okay, and login. Right, connectivity, yes. So now it is going to use EC2 user and it's going to connect. Perfect. Right, so now EC2 user is connected. Now go to my PEM file location, browse, then downloads. Okay, okay. Then here I can find my PEM. Right now here I require the PEM, not the PPK. This is the one. Drag and drop, right? So I drag and drop it here. So this PEM is copied under the home EC2 user. Whatever the user, I'm not going to bother about it here. So let me go here and cd home EC2 user and see. Right, the PEM I can found it here. So now here this one I'm going to copy into where? into the root. So from here, suppose from here I am going to connect. So this one I'm going to copy into the root user. So copy anywhere. This is not like you have to use the root only, right? You can connect from anywhere. I'm trying to use the root here. That's it. So copy home EC2 user, then Shankar. Right? So where root or my current location. Already if I am in the root, use current ls. Right? SSH EC2 user at the rate. So now I am going to use my SSH and the private server now. Private server IP, copy, and private server IP, then hyphen I. Hyphen I nothing but your PEM file path. Then my PEM file is Shankar 15. Yes. Right. So unprotected private key file. Right. So this is right. So this file is not protected. There is a reason it is denying. It is not allowing me. So let's see ls hyphen l. Right. There is a write. There is a write operation, right? So this private key should not be modified, right? Should not be touched by anyone. It's a private key. So now here I am going to change it. Chmod. Only the read permission I am going to give for the owner and the rest of all 00 on the file. Shankar 15 ls hyphen l. Now it is protected. Only the read permission to the owner. Nothing to group or others. So now let me connect it again. Perfect. Now we can see here from 155, right? 10.0.1 is the public, 10.0.2 is the private, right? We have connected to the private one. Now try to ping google.com. Not possible because, right? Because we are not given internet access to the private server. Internet gateway is not attached to this particular subnet. Which subnet? Private subnet. So likewise, we are going to restrict the servers to access the internet. Otherwise, there is a chance of hack your servers. Right? If you don't have the internet connectivity, obviously, no one can hack your servers. Likewise, we are going to protect the private servers. Right? Fine. Good. Well, so now the thing is, now the problem here is, suppose in my private, what kind of servers I am going to launch? Usually, we are going to launch the servers called DB servers. Usually the DB servers are going to launch as the private. So now here I need to update my servers, right? So suppose MySQL 5.8 is running on my private server. Now MySQL is launched 5.9, the version. So now your servers are running with the 5.8. So now here you require the 5.9 to get the latest features. Now by that time you require the connectivity of the internet so that you can update your servers. Right? Again, there are multiple ways, guys. Here, multiple ways to do this such kind of activities. The one is connect to the internet, update your versions of the tools. The second one is safest way. Don't provide any kind of internet connectivity to the servers. Download the patches. If you guys remember GitHub Enterprise, I have explained, right, the how to update the GitHub Enterprise the same way. Download the patches into the public servers, into your public servers, then connect to the private server, something like that, secure connection. So then transfer the package into this private server, then install it. That is one way, right? So that is the safest way. So now even though if I download the package, the particular version into my public server, then I copied the version into the private server, nothing but my suppose my GitHub or something or this SQL. Then when I'm trying to update, by that time the package still needs the internet connectivity to download some dependencies, even though I download into my local. Then obviously requires the internet. Likewise, certain cases will be there. In that cases, you require the internet connectivity. As an example, I'm trying to give you like this. Now here, when you want the internet connectivity, you should not connect the internet gateway to a private server. That is a very risky. So now there is a safest process. There is a safest process is there. So to provide the internet connectivity to your private subnets. Private subnet means whatever the servers are there in the private subnet, all will be belongs to the private. Now your private servers requires internet connectivity. For that we have a safest process. The safest process we are going to call as a NAT, network address translators. So these guys will take your private servers, and these guys will use only one certain IP, one particular IP to connect to the internet, so that no one can connect to the servers, right? IP, right? Suppose Shankar try to hack the servers. Now Shankar IP is 127.1.2.4. It is not going to allow me, because the in NAT gateway, what the NAT gateway will do, it will take only one IP to have the communication. So now this your IP is not matching. That's it. Reject it. No, right. So likewise, your NAT gateways will use one particular IP. The particular IP is going to take care of the actions. Nothing but the actions are nothing but to update or to download, whatever will be happen. The actions are going to happen to that particular IP, not with any other IPs. If I give the internet gateway, now the internet gateway is open for everyone. Now Shankar can connect, Chris can connect, Raj can connect, right? Vishnu can connect, like anyone can connect, right? That is a risky. So right, that's where NAT will comes into the picture, right? So NATs are nothing but network address translators. Now the purpose of the NAT is to have a communication to the internet, from the internet to the your private servers, right? So earlier days they used to have a NAT servers. Actually NAT servers will be there. NAT servers are going to launch. With the servers, this internet communication is going to happen to your private servers. Now what the AWS did here is, so you don't require to go the NAT gateway, NAT internet, NAT servers. I'm going to provide a easiest option, I think, but NAT gateways, like the internet gateways. You don't require to launch any separate NAT servers. Let's use the gateway like how you use the internet gateway. In the same way, use the NAT gateways. Like given a simplest solution for us, instead of go with the traditional process. Traditional process nothing but launch the NAT servers and communicate from the NAT server to your private servers. Right. So let's see. Let now here I'm going to stop it here. Then we'll go to the document again. Then here, right, this is the NAT instance setup, guys. So now we don't require to do this all the process, because this is the NAT setup, instance setup. This is so you can ignore this part. You can go with the NAT gateway. When you have the easiest process, why should I go for the complicated one? So now here, create a NAT gateway, and right, so now the point should be here where these NAT instances or NAT gateways are going to launch. Right. So those should be on the public, right? Because your end goal is your private servers has to get the internet connectivity, your private server. So now from where the internet you are going to get from the public subnets. Right? Because public subnets are connected to the internet gateways via the public route table. So now we'll get the internet connectivity from the public subnets only. Right? So that is the reason this NAT gateway or NAT instances we are going to launch at the public. Public means public subnet. From that public subnet, you are going to connect to the private subnet by using the what? The particular IP. One IP is going to take by NAT. Right. So now here, so the first thing will be create an NAT gateway, then the subnet must be the public. So now here, let me go to our VPC, then choose the subnet gateways. VPC. Right. So here you can find what is called NAT gateways. This is the one. NAT gateway. And as of now, nothing is there. Create the NAT gateway. Gateway. Some name. Then here, as I said, subnet should be public. 1.0, right? 1. There are 4 subnets are there. These 2 all belongs to the default subnets. Then these 2 are our subnets. This is also default. So now here you need to launch this NAT gateway in the public 10.0.1.0. Right. So here elastic IP. As I said, right, it's going to use one IP for the communication. I don't have any IPs upfront, so allocate. So now this IP is going to use the NAT gateways. This EP, EAP, LX something means this is the IP actually. This is IP. So scroll down and create the NAT gateway. Now this connected to our VPC and connect to the public subnet. Now the NAT gateway is ready. Now once the NAT gateway is ready, then the communication you have to build. So now here let's click on the create new elastic IP, something that is fine. So now the communication we are going to build. So once after the creation, go to the route table and select the default. Right. So now here you have to go to the route table. Which route table here? I am not going to use the public route table. If I use the public route table, the public route table is connected to the internet gateway. Then no use, right? No use of NAT gateways. You are giving the access to everyone. So now here you need to go to the route table. The default are nothing but the private route table. Now the private route table will be connected to the NAT gateway. Right. So now here I will go to the route tables, and here from that I am going to take the default private one. So this is the internet route table which is already attached to the public subnet. So now this is the one which launched as a default. So I'm going to select this default one. Then here you can see routes. Click on the routes, then edit the routes, click on add. So 000, then here I am going to select NAT gateway. Earlier we used the internet gateway, now I'm going to do the NAT gateway. This is the one. Perfect. So this is the one. Now save, close. Right. So now the public sorry, not the public is. Now the private route table is connected with the NAT gateway. Now this NAT gateway is launched on the public subnet. Now the public subnet is having the internet connectivity. Right. So right, see here the connectivity links, guys. Right. So now here, now public will go with the internet gateway. That is fine. Now the private subnet is not having any kind of internet connectivity, but the private subnet is connected to, not the subnet again. Private route table is connected to our NAT gateways. Now NAT gateway using the elastic IP to connect your servers of what? Private servers from the public subnet. Like the link is going to establish. So now here, once it is done, right, we need to attach subnet also, I think. Actually this is the picture actually, right? So now here the NAT gateway is launched here. So now the NAT gateway, your private instance are going to use the NAT gateway. Now the NAT gateway is going to the public subnet. The public subnet is the route table to the internet. This is the flow. Now here this is going to take care by the elastic IP. The only doubt here is I need to attach the private subnet. Let's see. Otherwise, I'm going to attach it. So I'm going to connect to the private subnet here. Now, right, already I'm in the private subnet. Now let me try to ping it. Right, we do it. Right. So now here you can see. Now the private subnet means the private servers which are launched in the private subnet, those can access the internet gateway. Internet gateway is nothing but internet access. Right. So likewise, we are going to provide the internet access to the private servers which are launched under the private subnet with the help of NAT gateways. Right. So this is the one thing. Right. But as well, max 95%, we are not going to go with this process until unless we require the internet. Otherwise, we will take this the content to the public server, then copy to the private server, then do the actions. That's what the practice we are going to do. But in that case also, if we require the internet access, then this process we are going to follow NAT gateways or the NAT instances. Right. So now this is one thing, guys. So now here we have in our diagram, right? So this is the right now we are at this phase. Yeah, so now we have launched the servers on the public and private, and then the public servers directly connect to the internet gateway. They are given the internet access. But for the private servers, we are not having the internet access by default. To get the internet access, we have used the NAT gateways. Done. So now this is the part. The last part is network ACLs. Right. So usually they will ask, do you know how to set up the VPC? We need to explain all the setup. All the setup means yes, I do. Right, so how we are going to submit right VPC, and once the VPC created, we are going to create the subnet so that whatever servers I want to launch, those servers will be go to the public, nothing but the front end public facing, and whatever sensitive data will be there like the DBs, we are going to launch in the private. There should not be have any kind of internet access. So then once the subnets are defined, then we need to define the route tables so that what kind of traffic you want to route to your servers. So that will be defined under the route tables. Now the that as a default, once the VPC is created, we will get the default route table, one NACL and one security group. So now we are going to create the route tables based on the use cases. Like if I want to route the traffic, public traffic, I'm going to use the public route table. If I want to send the traffic to the private, then I'm going to use the private route table. Right, then to open the connectivity to my VPC, like the public facing, so for that we require the internet connection. So there we are going to create the internet gateways. The internet gateways are going to attach to the VPC. So once the internet gateway is attached to the VPC, then the web servers, like whatever servers we are going to launch on the public subnet, those servers require the public facing access. Now for that, we are going to connect this internet gateway to the public route table. Then the public route table is going to associate with the public subnet so that the servers are going to get the connectivity. Now when it comes to the private subnet, whatever the servers like the DBs which we have launched the servers in the private subnet, those are not going to have any kind of internet access. So when you require like the updates, when I want to update the patches by the time if I require the internet access, then we are going to use the NAT gateways. The NAT gateways are going to launch on the public subnet, and the NAT gateways are going to use the private subnet, the routing from the private route table. From the private route table is going to connect to the private server with the help of elastic IP. One elastic IP is going to use by our NAT gateways. That this is the process which we need to explain, guys. Right. So now they will ask in that area, they will ask definitely this question: what is the difference between your NACL and the security group? Right, security group and NACL. Right. Let's discuss about the NACL. Then I will discuss about this difference. This is the as usual question for us. From the VPS point, they will ask what is NACL, why I require to use it. Yeah. So first discuss about the NACL now. So what the NACL here is. So NACL is nothing but network access control list. Right. So that is going to control your inbound and outbound traffic. Right. So now here that as a default we'll get one NACL default, right? So I'm going to create one more NACL. So for that, let me go to NACL. We are going to see one default NACL. This is the one, right? So I'm going to create one more NACL, my web NACL. That VPC is my own VPC, right? Create it. Now two network access control list are there, right? So here this guy is associated with the two subnets, right? So when I say web NACL means, right, the public facing traffic, right, internet one, right? So now this guy required the access of the public subnet so that whatever the servers are launched in the public subnet, so now the traffic will go to the public subnet via the this NACL. NACL nothing but it is going to restrict the inbound and outbound traffic. Right. So now here once this NACL is created, so now here the point here is by default, when the private NACLs are created, inbound and unbound are denied state. It is not going to allow anything here by default, right? So now here you need to define your inbound and outbound traffic, rules. Then your network ACL will go and allow the traffic to your servers, right? To your servers means to your subnets. Now from the subnet to the servers. Right. So now here what I'm going to do, I'm going to allow the traffic to my servers with the help of this NACL. So by default already these two are open to the default subnet. Now what I'm going to do, I will go to my web NACL, whatever the subnet I created. So now here if I go to the NACL, then there I can see inbound rule and outbound rule. As we discussed, by default deny, outbound deny, default behavior that is. So now here all traffic. So I will go to the inbound rule, then I'm going to edit the inbound rules. Okay. So now I'm going to add a rule here. The rule I'm going to give it as some number 10. SSH shallow add rule 20. HTTP shallow add rule 30. Here I'm giving all traffic. All save. Now we'll go to the outbound rules. That outbound rule also be allowed. Otherwise, you will receive a request, but you cannot respond back. So edit because by default deny. Add rule 10 SSH. The same I'm going to use SSH. Anyone allow 20 HTTP allow 30 all traffic allow. Right. So now this my web NACL opened with this post actually 2280 all. So now this guy has to be attached to what? To the subnets. Which servers has to be restricted? The traffic, right? The traffic has to be restricted on what servers, right? By default, private, right? Private, we are not going to bother because we are not going to give any kind of internet access to the private server. Always our worry is on the public server, right? So now I'll go to the subnet association. Then here, edit the subnet association. Then here, I will go to the public. Select the public one. Edit. Right. So now here, let me go to the private subnet. Sorry, private network ACL. And here I can see 10.2.0 is attached here. Is selected here. Define over this. Cancel. Okay, fine. So now no worries. Now here, now my web NACL, whatever the network ACL I have created, this network ACL is attached to the public subnet, and the inbound rules and outbound rules are defined here. Right. So now here, what I'm going to do, let me go to my server, exit, because I'm on the private. Now I am on the public server, one series 10.0.1. Yum install httpd -y service httpd start service httpd status. Apache is running. Right. So now here, what I will do, I will go to my EC2. Then I will take the public IP of the public server. Then public IP will get the public server, not for the private. So I will go to my servers and take the public server and try to access it. Perfect. Right. So now here Okay, fine. There is no big deal here, right? So I installed Apache. I try to access it. That is fine. So now here, let me go here again and go to the VPC. Now here, go to NACS, Network Access Control List. Where it is. This is on security. Network Access Control List. So from that, again, I will go to my web. Then here I will go to the inbound rules. Now here, click on edit the inbound rules. Now here, 80, I am going to deny it. Save, outbound, edit, 80, I am going to deny it, save. So if I am trying to access it, now it should be blocked. See, it is rotating. So it is blocked actually. That is the reason it is rotating. So after some point of view here, you can see the page of the HTTP server test the page. It's trying to reach the server. Finally, yes, perfect. Right. So now here the observation here is right. This is my server. Suppose if I take this is a server, right? This server will be attached with what? Security groups. And this is my security group. Now in the security group, we are going to tell what are the ports has to be allowed. 80, 80, 80, 3306, 22 like. Right. So now here, when you open the security group, then only these ports are going to allow into the server. Right? That's what the security group. So now if you take the security group, the security groups are belongs to server level. That means each server will be having their own security group. Correct or not? Right? So correct. So again, this is one more web server. Right? So this is one more web server, web one. Now this web server again will be having their own security group. Now here again I am going to define right what should be allowed or what should not be allowed. Right? So now here if this server right now we know these servers will be under a subnet, right or not, right or wrong, right? So right, just now you have seen now all the servers, what are the servers you are launching, that will be under a subnet. Now this subnet can be a private subnet or public subnet. Suppose if I take the public subnet, right? So now this public subnet will be controlled by network ACLs. Right. Right. So now two layers of authentication or not authentication restriction for the traffic. One is server level security group. So we are restricting the traffic. One is server level security group. The second one is subnet level security group. Now the subnet level security groups are nothing but whatever the restrictions I am mentioning here on the NACL part. Right. So now here I am allowing 22. I am allowing 80. That's it. I am not allowing any other ports. Right. So now here, even though I have opened the 33068080, no use because on the NACL level, I am restricting the traffic. I am going to allow only 22 and 80. Even though I have opened the other ports here. You have to open those ports also here. Then only this traffic 8080 and 3306 will be allowed. Otherwise, no use. Right. So now here, the thing is server level security will be the security group, server level. Subnet level security group with NSL means whatever the servers you are going to launch inside the subnet, right? So now I can launch max of 255 servers in the subnet with the VPC. All the 255 servers will be restricted with the NACL, right? So now likewise, now server, now they will ask what is the difference between the security group and NACL, right? So now here security groups are belongs to the server level, individual server, right? NACLs are belongs to subnet. So that whatever the servers we are going to launch under the subnet, all the servers will be restricted with the help of NACL. That is the one point you guys need to tell. And the second point, anywhere you have seen that security groups is having an option of deny? No. Security groups are not going to have any kind of option called deny. Only you have to open the port or don't open the port. That's it. But for the NACL, we are going to see there is an option called deny, allow or deny. Right? What is the use here? That's what the case I have tried to explain here now. So now here the use case will be right. So here I have opened the port 80 earlier so that I can reach the Apache. Now what I did, I have restrict the port 80. Right. So now here my requirement is I need to open all the ports, but I need to restrict the port 80. Zero to the series that all traffic means 0 to 65,535, right? So I need to open all, but certain ports has to be restricted. Now with the security groups, can you do that? Yes, you can do, but like you need to write many entries. Right. Suppose I want to restrict 84, I want to restrict 8080, I want to restrict 9090. Then in the security group, you need to write the security group for 1 to 79. Then 81 to 8079. Then from 8081 to like that, you need to write the like if I want to block 10 to 15 minutes, now your security group rules will become complexity, will become complex. Now here in our NACL, right? So you don't need to write something like that. Simply you can write a rule. What are the ports you want to plug with the help of deny. Now how this NACL will understand that this has to be taken first, right? So now if you guys observe here, I have opened the all traffic. I have opened the all traffic means 80 is also part of the all traffic, but here I have mentioned block 80. Now how this NACL will understand? I should take this one as a I should give the priority for this one, not to this one, with the help of the rules, right? So now your NAC will understand that whatever the least number will be there, that will be the high priority in the rules. Now when I compare against the 20 and 30, now 30 is the least. Now 20 will be taken as the priority. That is the reason before take consider all traffic, it will consider the 20. So 8 is blocked. Likewise, based on the rules, your NACL will act. Now the act is nothing but the actions, right? The rules can be utilized like this, but this kind of facility is not available on the security groups. You cannot deny it. This is the second option. You need to tell when they are asking about the security groups and the NACL part. Got
Shankar,
it? Yes, Chris.
can we have the same rule number or no? We cannot have.
No. You cannot have. Duplicates are not allowed.
Okay.
Okay. So you can write from 1 to 100,000, but the thing is, whatever the rule you want to make it as a priority, like it is a high priority to the NACL, then give a least number. If I give 40 here, if I give 30 here, then it will be allowed the 80 also, because 30 will become as a priority for the NACL.
Question. So
Sorry,
let's
please.
say the R traffic is 20 and HTTP is 30, then it will be allowed.
Correct. That's what, right? So that's what I'm trying to explain you. So the
The,
least, right, when I change the order, then obviously 80 will be allowed, because the 30 will become the rule. Suppose here I have given the 40, now the 30, right? So then what will happen? Now 30 will become the high priority for the NACL. See, now 40 will be the low priority. The order got changed. So now it should be allow the traffic. So I need to change that outbound rule also. So I have changed the outbound rules. Let me change it's still the inbound is not changed. Let me change the inbound also. 40. So now both inbound and outbounds are changed. Now that the priority got changed, so your server will allow the traffic. Right.
Okay.
So yes, likewise, these are going to play a vital role here. The rules are going to play a vital role in the NACL part actually. Right. This
Okay.
is the yeah.
Because the reason why I asked is usually networking, deny always overrides allow.
So, your voice is somewhat breaking, Chris. Actually, I didn't get you.
The reason why I asked is usually deny always overrides allow.
Ah,
That's
deny
why
always.
looks like the rules are overwriting. So here
Correct.
in the
Correct.
VPC rules are okay. Yeah, rules are the one that actually
Yeah.
make work or break. Yeah. Okay. Got it. Got it. Thank you.
Yeah. Correct. Yes. Yes. The rules are going to play a vital role here. Actually. Yeah. So right. So this is the common intro question for us actually. What is the difference between SG and NACLs? Yes. So this is about VPC, guys. Okay. So like how we are going to set up this VPC. So I am going to take a small break here, 10 minutes, not the 15 minutes. Let's take a 10 minutes break. Then we'll come back and we'll see the other services like Route 53 and I think CloudWatch, Lambda. Three services are left. We'll try to cover the three after the break. Okay.
Thank you, Shankar.
Hope
This
everyone is back.
conference will now be recorded.
Shankar.
Yeah, thanks, Ramesh. Okay, right. So cleaning up the content. Right? So if I want to clean up the resources which I have launched, so for that go to the VPCs and try to delete the VPC. So I'm unable to delete the VPC because contain one or more instances, network ACLs are there. So it is asking us to delete this stuff first so that I can delete the other stuff. So that's where our cloud formation will be handy, right? So see here, many components or many services we have launched as part of the VPC, right? Network gateways, internet gateways, subnets, route tables, like many things are there. Right. So now here when you are trying to launch a infrastructure with these components, there are some certain components still we are going to launch the auto scaling, load balancers, right? Now those will be also part of your infrastructure. So when you are going to set up this complete infrastructure like the manual, and when you want to update it or when you want to delete it or when you want to recreate it, it will be a time-taken process. If you miss one thing, it is going to mess up the other things, right? So there the templates, cloud formation will be handy for us, right? Put everything in a template, launch it whenever you want, right? When you don't want, delete the template so that you will take care of deletion of everything. When you want to update the template, relaunch it. That's where the scripts are very, very handy for us. So, right. So to delete this, first I need to delete the NAT gateways, then I need to delete the NACL, and I need to delete the instances, services, EC2, instances. Okay, fine. So now you guys will understand, right? So if you want to delete, you have to take care of deletion of all the stuff. I will delete later. So let me go to the other service called CloudWatch. Right. So in our AWS, we have a service called CloudWatch. So CloudWatch is nothing but monitoring service in the AWS. To monitor your services, so the service CloudWatch will be taken care. So now in the CloudWatch, you are going to see different options here: dashboards, alarms, logs, and metrics and events. So dashboard is pretty simple, right? So when you want to create your own dashboard, you can go to the dashboard and you can create the dashboard. So click on create dashboard and my web servers or web servers, not my. Create the dashboard, right? The visualization, right? So I want to visualize this dashboard with the line format. Click on the line, Right. So now here, what kind of data you want to monitor? You want to monitor the logs or you want to monitor the metrics? Suppose if I click on the metrics, configure. So here we are going to see all the metrics, load balancer metrics, volume metrics, distance metrics, file system, right? EFS, ELBs, again NAT gateways, like whatever the services here, the list whatever saying here is whatever the services you have launched so far on this AWS account, right? I have created RDS. We have seen the SNS topic. We have used it, like the volumes and other stuff. EFS, we have used EFS, ELBs, NAT gateways, right? Those metrics are going to show here because these services you have launched so far. So now when you want to monitor my instance, so I will go to the instance. So then here auto scaling wise metrics and instance wise metrics. So 406 metrics are there. So I'm going to click on the per instance metrics. So then here you can see the metrics list. Somewhere the expansion will be there. So actually it is this list will be here actually. So I need to expand it. Should be expansion. Dashboards, web servers, and here the web servers, widget. Next, metrics, configure. Yes, actually this is the one. EC2, for instance, the same story.
Maybe change the zoom on the browser.
What is on the browser?
Yeah, on the browser you can change the zoom, isn't it?
Okay, yeah, it's a good idea. Yes, perfect. Yeah. Yes, so here we can see we have the instances gate, private, and our one of the instance, right? So here the thing is again based on the zones it is going to show us. So it is going to show me the git and private servers, not the public one. So those are belongs to some other zone actually. So let me take the private server. Suppose when the private server I'm going to monitor. Now here you can see the private server, select and create the widget. It is going to launch, it is going to monitor the CPU credit balance. So now here if I go and edit, if I want to add more, I can add more metrics also here. EC2 for instance. So these are the two metrics it is showing for me here for the gate. And if I go to EC2 for instance, already have launched this one. Go to services, EC2 here. Two are there. Now out of the two, git and the private are launched in the 2B. So the 2B zone servers only it's showing in the list actually. So let me add this one. Now go to the CloudWatch. Go to the dashboards. So let me delete the stuff. Delete the dashboard. Delete. Create the dashboard. Web servers. Create it. Some selection. Metrics. Configure. EC2 for instance. CPU users will be given something. So here. Okay. Ohio. Under the Ohio. This is to here the all. Here the volume levels. This is to instances. I should see an option of selecting the zones as well, so that I will get other instances also. That's what I'm looking for actually. My private and public. It is now showing the list here. Okay, here's some one more. Yeah, here it is having actually because of this screen size, we are not able to see this one. So here instance name. Yeah, you can see here all the servers. Perfect. So it is showing actually all the servers, but here the option is not showing here. That is the reason I'm not able to select that one. So now here let me go. These are all the metrics. So now here from the list of the metrics, yes, these are all the metrics. Okay. So now here, so this is the mention. So here I want to see CPU utilization. So CPU create, CPU memory. Yes, this is the one. So CPU utilization for the instance called Git. Likewise, I want to see the CPU utilization for my data server also. So these are all the Git instance. Now here private server. Now this is the private server and this is the CPU utilization. Select it. So likewise, I want to see the CPU utilization for my other server also, public server. Right now I'm in the public server, and here let me go and see the CPU utilization option. Public server, right? Public is started here. CPU create, CPU. Yes, this is the one. Right. Like all the server CPU utilization, I want to see actually. Right. So that's where I have created this dashboard. Now create the widget. So like dashboards are nothing but that easy visualization, right? So now here you can see this blue color is representing Git and orange color is representing private and green color representing public. So when I place my cursor on the public, so this is the public server CPU utilization. When I place on the right, so orange here, that is what my CPU for the private, like Git. Right, like all the servers utilization you can observe here. So now here you can see 1 hour, right? From the past 1 hour utilization or 3 hours utilization, 12 hours or 1 day, 3 day, 1 week. You can select the time frame also here. Or if you want to set up any custom, you can set up the custom time frames. These are the zones, time zones, UTC and local time zone. Likewise. Then here you can see the refresh, right? So it is going to monitor continuously by default 1 minute. So now here 10 seconds, you can change the refresh interval. So that is going to update, your dashboard is going to update. Right. So likewise, the dashboards, you can create the n number of dashboards so that in a single shot, you can monitor your servers. Like the servers means the rules, like what you want to monitor. So my priority is network, network in and network out, or the CPU utilization, or the disk allocation, like that. Now, for the particular rules or the group of rules, you can create the dashboard, and you can come to the dashboard, you can monitor straight away here, the easiest way. This is one thing. So now here, alarms. Right. So alarms are nothing but, so here from the CloudWatch side, so this CloudWatch service is a free service from the AWS. It is going to monitor every 5 minutes. Right, it is going to monitor your services every 5 minutes. So in the 5 minutes span, right? So whatever the monitoring is going to do. Suppose I want to see my utilization of the CPU. If the CPU utilization is beyond 75% on the server, immediately I need to take an action. Right. So the action should be either increase the missions like auto scaling, or I need a email. That's it. So when the 75% is reached, simply I need an email, or stop the instance. Like some action I want to perform. Right. So now here, okay, fine. So now who is going to monitor here? Your CloudWatch is going to monitor what? Your server. Now if you want to monitor continuously on the server, then it's going to monitor whatever the rule I am going to define. So now here my rule is, if the CPU utilization is greater than 70%. So now here this CPU utilization is going to monitor by CloudWatch. So once the 75% is reached, then my requirement is I need an email. Now the action is sending an email, or stop the instance, or create a new instance. The action has to be performed. Now who is going to perform the action? Let's whatever the service, right? Suppose I want to stop the instance. Now to stop the instance, I'm going to use a lambda functions, or some my shell scripts or something. Now these guys are going to take care of the action, and they must stop the instance, right? So who is going to tell to trigger that action? Right. So that guy nothing but the alarms. Now alarms are nothing but, so these guys are going to raise the alarm. Now raise the alarm means whenever the rule, what is the rule you have written, when the rule is met, the alarm is going to trigger. When the alarm is triggered, then it's going to ask the other guy. The other guy is nothing but your lambda functions or some XYZ to perform the action. So this is where the alarms are going to play the role here. So now here, click on the alarms. As of now, no alarms are there. Now create an alarm here. So now we observe this alarm in our auto scaling. Right? So when I set up the auto scaling in the background, alarms are created. Right. So now here, create the alarm, then select the metric, right? The rule on which, right? What is the rule you want to set up? So suppose I want to set up the rule on the CPU utilization. So EC2 for instances, and here again, let me minimize. Right, suppose so on the gate. And the gate I want to set up the CPU utilization. This is the one I would like to monitor it. So I have select the metric, and here we are going to write the rule, right? So now here my rule is nothing but the CPU utilization on the instance called git. So now the static average, the CPU utilization average, the period of 5 minutes, you can set up. Suppose 1 minute, right? So now what is the period here? So the period of 1 minute, the utilization is continuously 70%. Right. Otherwise, what will happen? Right now, the time is 12:24. 12:24.1 second, the CPU utilization is 80%. Now, the 12:24.5 second, the CPU utilization become 60%. Now, for that 1 second, 2 seconds, you should not trigger the alarm. Right? It's a kind of high spike. It may be network issue or some other thing. Just at that moment, that second or 2 seconds, your utilization is high, but not like it's a continuous. Immediately, it bring down. So by that unnecessarily you don't trigger the alarm. So now you need to wait for some time, like 2 minutes, 5 minutes, 1 minute, something like that. So throughout the 1 minute or throughout the 5 minutes, if the utilization is continuously 70%, then yes, my like the usage on the server is high, so then take an action. So that's what here the period. So the period of 1 minute, my CPU utilization, right? So now here I'm going to give the threshold value. Is continuously the threshold value, then yes, take an action here. So now here what period of the static value is greater than, here I am going to give 70%. Right, so now average my CPU utilization average for 1 minute of period is greater than 70%. Then yes, I want to take an action. Click on next. 1 minute, 70%. Click on next. What it is? It is an alarm. Right. So if it is greater than 70%, now alarm. It is alarm. Right. I need to do some kind of action. Alarm. That's what you guys can observe, right? Okay, insufficient data. Insufficient data means your CPU utilization is good, right? It is not having beyond the threshold value, insufficient. Okay, right? Once the operation is performed, it is okay. Then alarm means once the threshold value is met. So now here, right? So here what you want to do, right? So I want to send a notification, right? Already we have created an email, right? So now here who is going to receive the notification? This person, right? Or you want to create a new mission, auto scaling action, right? We have seen this one. Or you want to take an action like I want to stop the server immediately once the CPU is greater than 70%. Add an action here. Stop the instance. Terminate. Reboot. So like that. So like that, right? So like that, these alarms are going to play the role. Like whatever the rule you have written, it is going to monitor based on the rule. If the rule threshold value is met, then immediately either you can send a notification or you can add a mission auto scaling group, right? You can add a auto scaling policy or you can take an action on the mission, stop, terminate, reboot. Like that, you can perform the actions. So now here my requirement is just I need email so that later on I'm going to perform action. So for that, I have taken the SNS topic, email will be received. And then next, that alarm name, git server CPU utilization. CPU is greater than 70%. Email will be sent. Next. That's it. Likewise, we can create the alarms. So like now here we can have the number of metrics. Right? So now you can choose the metrics and you can create the alarm. Now you can leave it. So now see insufficient data, there was no data is available. If the data points are good. So once the server is active, once the data is loading, then it will continuously go to monitor it here. Now, right. So here my condition threshold value 70%. Now it is not getting the data. Once the data is pumped up, then this is the time frame for every 5 minutes, right? As I said, every 5 minutes your cloud watch is going to monitor 4 o'clock, 4, 5, 4, 10, 4:50, like that you can see here. Right. So like that you can see the monitoring part, and these are the data points whatever we have configured. The period of 1 minute will be around 70%. I want to send an email like that. Right. So these are the alarm setup, guys. Right. So likewise you can create a number of alarms. Right. So then the second one is logs. The third one, right? Dashboard, alarms, and logs. Right? The logs are nothing but, right? So streaming, right? So the log streaming. The concept is log stream. So it is required for us actually the log streaming because your application is going to produce so much of logging. Right. So now here the events, the actions, what are the actions or the events are going to perform on the application in the background, it is going to generate the log for each and every action, the events. So now here at the end of the month, suppose if I take an example of Flipkart. So now the Flipkart owner or the manager ask us to, I want the report. Now the report should have the content of the customers who are not able to connect our application. Right. So because if at the end of the month, Flipkart means is a e-commerce very popular application. We are going to see huge amount of log. Now out of the log, if you want to get the list of content is nothing but the list of sorry, the list of persons who are not able to connect the Flipkart application. Now the reason might be from the customer side, right? My mobile network is having some issue. That is the reason I am cannot access the application. My internet is not good. That is the reason I am not able. That is fine because that is the issues from your end. But if the application is down for two minutes, 2 minutes, right, that is not a 2 minutes means it's a simple thing. But for the Flipkart side, it's a big thing for them. Like 2 minutes means is huge. By that time, whoever is trying to connect to the server, they are not able to connect it. Right. So now this kind of data they require actually, so that they are going to take care of the proper action so that 24/7 your application should be reachable to the customers, right? So now here, if the problem is from the client side, customer side, we are good. If the problem is from our side, like from your server or the application, or suppose your application is taking huge amount of time, like every day morning 9 to night 10 o'clock, application working perfectly without any delays, without any issues, but after 10 o'clock there is a slight delay from the application response. 10:30 p.m. of IST, we are seeing some delay response from the application. There is an issue, right? It should not be like that. So we have to take an action. Like how I am going to know all these criteria, all this information, right? So application is delaying, or application not responding, or sometimes application I am not able to reach. I means the customer is not able to do the application. So these information how they are going to get through the logs, right? So now the logs is going to give the information, right? So they are the persons when they are trying to reach the application is throwing an error 400, 401, not reachable. Right? This is the code. Like so now server is down. So to something like 201, right? Server is not responding. Right? So like that, you will get the information, the data from the logs, and will try to resolve the issues. The logs are going to play a vital role here. But the problem is, if I take the month log of the Flipkart, there are millions of records we are going to see. Out of the millions of records, how we are going to get the required information? That is a very big question mark, right? So you have to spend huge amount of time to get the information, whatever you are looking for. Right? That's where we are going to call it the log streaming. Right? Log streaming is very, very important in our DevOps actually, right? There are different tools available in the market. Splunk, ELKs, right? So now here in our CloudWatch, the log streaming facility is available actually. Very, very few people will come to know the log streaming from the CloudWatch actually, right? But the CloudWatch is a capable of, it can do the log streaming for us, right? Like the Splunk, like the ELKs, how the tools are going to work. Like this CloudWatch will also work the same, right? So people will ask us when you do you have the experience with the log streaming? You can tell like this is like yes I have set up on the CloudWatch side the log streaming. Right? So let's see how to set up the log streaming. So for that, we are going to use the logs option of the CloudWatch. This is the one, right? So now to set up the log streaming from the AWS side, so that is nothing but our CloudWatch. Right. So see here, guys. Now CloudWatch is not only for the monitoring purpose. The CloudWatch can be utilized for to do the log streaming. Also, the CloudWatch can be used for to do the cron jobs. Also, you can set up the cron jobs with the help of CloudWatch. Right. Very important service in the AWS is the CloudWatch actually. It can do many things apart from the monitoring. Right. Right. So now here before going to that, just I will show you something. So usually you don't require to monitor your servers always to the CloudWatch. Right. So the server itself will be having the monitoring information. So you don't need to go to the CloudWatch always. Suppose if I go to the instances, if I select the instance Git, here you can see the option monitoring. Likewise, every service will be having a tab called monitoring, so that the particular service can you can see the service monitoring details here. CPU utilization, disk rates, disk operations, like many things you can observe here. If you want to set up the alarms, or if you want to set up the dashboards like that, then you can go to the CloudWatch actually. Then otherwise you can see the data of the particular service on the monitoring tab. Like that. So you can verify it, and also you can create the alarms also from here. You can create the alarms also for the particular instance. So here, either way you can do that. So now here, now I am going to set up the log streaming. Right. So for that, we will go to the Shankar and right. So if you want to set up that kind of log streaming, right? So now here we need to do some kind of configuration, right? The configuration nothing but if I take the use case, right? So now here what prerequisites? Now the prerequisite nothing but usually what the CloudWatch logs will do, you will be right. So now application will be running on the servers, EC2 servers, correct? So now whatever the applications are deployed on the EC2 servers, the application logs you need to capture. Right. So now who is going to capture the application logs here? The agent. CloudWatch agent is going to capture your server logs. Your server logs or what are the applications that deployed in the server, those logs. Okay. Right. So now here the first step will be you're required to install the agent. One second. Yeah. So now here we require the agent on the server where your applications are running. So now what the agent will do, it will capture the logs of that particular application, then it will push the logs to your CloudWatch. Now on the CloudWatch, you are going to set up the log filter, right? Because you don't require the millions of logs, the records. You require the data, whatever you're looking for. I want to see the persons who are not able to access my application. Means when the application is not able to access by the person, there the written code of the application will be 401. Those are the error codes actually. We will be having a different error codes. Internal server error 500, 401, not able to reach like that. So now I'm going to look for the error code. You write 401. Out of the millions of records, I am searching for 401 record. So who is going to do? This guy is going to do log filter. So now if the error code is found, then I need a alert. That's now the thing is log streaming is nothing but you have to monitor continuously. So now here the report, I'm not looking for the report. Whenever something happened with the application, right? The application is not traceable, or the people are not able to access my application, or the application is giving us some delay, then immediately I need to take an action. I don't need to wait for 30 days or 40 days of the period. So there we can set up the alarms also. Now when the moment the person is not able to reach, when the moment the error code 401 is generated, immediately I need an alarm so that I will go and look at it why the application is not reachable, like that, email notification, right? So likewise you can set up this thing. Right? For that, what we need to do, right? We required a policy, right? The policy nothing but your server, your AWS instance has to reach the CloudWatch, then it has to send the logs to the CloudWatch. Now the AWS instance is required the CloudWatch access. So that so right, for that we are going to create a policy. The policy we are going to attach to the server. So then create IAM role for the instance and attach the policy. Right. So once the role is policy created, then attach the role to your IAM instance. Right. Then the configuration. Then finally create the group. Then finally do the stuff. Let's do that actually. Right. So for now here, what I'm going to do, let me create the policy. So take this policy. Nothing but it's going to take the actions on the logs, CloudWatch logs actually. Create the log group, create the log stream, put the log event. These are things which are required. So for that, we will go to services and IAM. Do you create any policies? Sometimes the people ask, yes, I do created. For what? This is the example you can tell. So policies. create a policy. Okay. This is through the what is called through the GA mode. Okay. So now I'm going to do what I'm going to do. I will go to the create policy, then I will go with the JSON. So here I'm going to add the code because we have the code, so I don't need to go with the GA. So then review policy, then EC2 with CloudWatch logs, some name, then create the policy. Right. So if I go to the customer policy, then you can see there is a policy which I can find EC2 with the CloudWatch logs. Perfect. So now here, once the policy is created, so then the next step is create IAM role for the EC2 instance and attach the policy. Right. So now I need to create a role and attach this policy. Right. So here what I'm going to do, let me go to the roles and create a role. Right, so for the EC2, right? For the EC2, I require this AWS permissions. Now here EC2 with, yes, this is the policy. Tags, review. So policy role also I'm going to give the same EC2 with CloudWatch logs. Something like that, right? Create. Now policy is created, and the policy for the policy I have created the role called EC2 with CloudWatch. Right. So now so that my instance can go and talk with that what is called my CloudWatch. Attach the role to the instance. Right. So now we know how to attach the role. Right. So either you can go what is called you can go to your instance and you can go to the instance settings. Then you can modify that one. Otherwise, while creating the instance, you can attach the role. But both the ways, before the instance, while creating the instance, or after the instance is created. Right. So now here, what I'm going to do, let me go to the public instances, then public server. Is the first server, right? The public server. Then what I'm going to do, go to the actions, instance settings. Then you can see attach or replace the assigned roles. Now here I'm going to attach my EC2 with logs. Apply. Simple. Right. So now here my public server now is connected with the role. So that now this public server is having an access of AWS. It can communicate. It can talk with the AWS. Right. So now perfect. Now this is the part done. Now the next thing will be configuration. Right. Before the configuration, we require to install the agent. Right. The first step will be that what are the applications running? The application is going to generate the logs. Now, once the logs are generated, these logs has to push to where? Into the CloudWatch. Now, there I'm going to create a log filter. So now, once the logs are coming into the CloudWatch, now your log filter is going to filter the logs based on the rule, whatever you are going to configure. So now here, the agent is nothing but AWS logs. It has to be installed on the server. Right. So now I'll go to the public server. 158 is the public server, right? So here I'm going to install AWS logs agent. Copy. So that your EC2 server is going to connect to the CloudWatch logs with the help of this agent. Install the logs. Then I require the configuration. Right. So because my application is going to generate the logs somewhere, the location called where log application.log. Now the application log I can find in the where log folder. Now from that application log is the file where I can find all the logs information for the application. Now this logs has to be pushed to the CloudWatch. Right. This configuration you need to do it. Right. So now for that we have two files. One is logs configuration called AWS. One is the CLI configuration and the second one is the logs configuration. Right. So now here where this configuration files we are going to find once the logs agent is installed. Now the logs agent configuration files you can find in the etc AWS logs. Right. So now let me go to the location cd once after the installation of agent, etc AWS logs. Right now you can see AWS CLI conf, AWS logs conf. These are the two files. Now open the AWS CLI conf via AWS CLI conf. Simple here you need to tell where, right, the zone or the region, not the, sorry, not the region, the zone. I'm confused, man. The region actually, sorry, not the zone. So which region your services are launched? Okay, let's now here my region US is 2. That is we are going to configure here. So now here by default it is giving 1. So I'm going to change it to 2 because at present my services are launched on the region called 2. That's it. Now save. Now once the region is configured, then application details has to be configured. So now for that, AWS logs.cf, CLF, AWS logs.conf, not the CLF. Via AWS logs.conf, here you can see all the configuration details for the particular agent, AWS logs agent. Huge amount of configuration I go to find. So now here, I don't require all the stuff. So whatever the options required for me, those I am going to configure here. So for that, what I am going to do, I am going to delete all the data. Then this is the configuration is enough for me. This configuration is enough for me. So I am going to place this configuration. So your date and time format and region is US East 1, not the AP South 1. Then you can say here the state file and blah blah blah. This is the one which is important for us, where the application logs are going to generate on the server. Right, so my application logs are generating in this, suppose this is the location. So if the location is different, then you need to provide that location. Right. So as of now, I'm taking where log inside that application log is the file where I can see all the logs details of my application. Right. So now this property is important. These are the default properties. You can leave it. So the required properties. So now here I'm going to save it. Then agent, start the agent. Once the configuration is done, then start the agent. So now here status, whether the agent is started or not. It is active. Now what will happen? Your agent will capture the logs from the so and so location, and from this, sorry, from the so and so location, from this file. From the file, the logs will be captured. Then it will be pushed to the AWS CloudWatch. Who is going to do? AWS logs agent is going to do. Now the next step, right? So next step is nothing but, so here I need to have the log file. That's I said, because I said my log file is so and so location where log application.log. Right. So as of now, here on my server, cd where log, then I don't have any cd where log, then I don't have any file called application.log. For this example, for this use case, just I have given the name called application.log. So now let me create the application.log file under the where log location with some data. Add some data. Okay. So here, this is the file I am going to create. vi application.log. So where I'm going to create here, I'm creating under the where log directory, because that is the path I have mentioned the configuration file. Right. So here add some data. some data I have added. So then save it. Right. So now here I have the application log file inside my var log. Inside my var log, here I can find the application.log file. Cat application.log. You can see some data is there. Perfect. So now here the next step. Go to the CloudWatch and go to the logs group. Right. So now here I will go to the CloudWatch services, CloudWatch. Go to the logs and here the logs group. Now here you can see the log group is automatically created once I set up the agent on my server. Right. So application underscore logs. If I click on the application underscore logs, this is the log stream details, nothing but my instance details, which server I have configured I04E, right? That is the instance details, my public server. Now you can see dummy data for CloudWatch logs. This is the date and time, right? So automatically, right, automatically, whenever the log is generating here in the application.log, so that log I can find it here on the CloudWatch. Who is doing this job? The agent. That the agent is doing the job. How the agent is going to get the access? That's what the policy. The policy I have created so that the policy will give the access to the AWS server so that your AWS server can connect with the AWS logs, CloudWatch logs. Now the agent successfully getting the data from the server, then is pushing the data into the CloudWatch logs here. Fine, absolutely fine. Very good. So now the thing is, I don't want all the data. This is the fine. The data is fine. Actions are performing and responding my server very good. I am looking for the data which is creating the problem to the end user. Right. So now the data is nothing but I am not able to reach the server. That is the problem. That the server is not responding properly. That is also a problem. Right. That data I'm looking for, not the common data. So there, what we are going to do, we are going to set up the log filter now. Now this is the log we are receiving. Now on top of the log, we are going to set up the log filter. Right. So now here, apply the filter on the logs, step 9. So now go to the log group and click on create metric filter. Right. So now what I'm going to do here, now I will go to my CloudWatch, go to the log group. Let's see here, create metric filter. It will be disabled. You have to select this option so that it will be enabled. Create metric filter. So now here my filter pattern is error. This is the error, right? So if I found the error keyword on the records, now I need the alarm. I need the alarm so that I want to perform the action immediately, so that the end user is not going to face the problem again. Right. So now here just test it. Now it is going to test the data on the data, this error code, right? Out of 7 records, nothing is matching means I'm good. Right. So now here filter pattern, nothing but what kind of error codes or what you are looking for actually from the log, what you are looking for. Sometimes you are looking for the error codes 401, 50, 500 like that. Then give the error code like that. The pattern is nothing but what you want to search. Now assign the metric. Right. So now here this is the error code which I am looking for the filter. Then this is the metric which I need to define. Right. So metric name is I'm going to give error only. Right. So here you can observe here. Right. So error file pattern I have given. Then here assign the metric. So now here you can see you can give any name, cap error, whatever the name, so that the alarm is going to create with the name actually. So the filter is going to create with that. So here I have given error. Otherwise for anything is fine. Application errors. Application errors. Now create the filter. Now here you can see filter is created with the name app errors. Right. So now what the filter will do, it will try to search for the error keyword on the records, on the log records. Okay, fine. So suppose if the error code is found, then what is the next step? What you want to do? Right. That's where the alarm. The next step is I want to raise alarm immediately once it is got found. Create alarm. So now here the sum on the error code for period of 5 minutes. So continuous monitoring, right? So or for period of 1 minute, I can change it. Like the same thing. Alarms are same. Right? So if the error codes are greater than zero, right? If I at least if I found one error code, immediately I need an alarm. Every minute, is going to check the error, check the records. If any record is having the error code, then what will happen is going to trigger alarm. So that's why I give it greater than zero. At least if I found one, I need the alarm. Right. Suppose every minute 12:55 is going to start. 12:56, 55 to 51, 56, 51 to 55 to 56. If any, there are 10 log records are generated. 10 logs are generated. In the 10 logs, if any error code is found, it's going to raise an alarm. Let's suppose two records are having with the error code. Error. Then greater than zero, two means greater than zero. Trigger alarm. Now 10:50, sorry, 12:56 to 57. Now the past data is not going to consider the past data. It's going to consider the latest data, 56 to 57. In the 56 to 57, if any log record is having a code, a word with error, then it's going to raise an alarm. Otherwise, it is not going to raise an alarm. Like that. Like that is going to, your alarm going to work. Then next. What you want to do? Just I need a email. Like you can prioritize, this action now. So now select a search topic. I want email. That's it. Next. Alarm name, application error, email. Next. Create it. That's it. So now once the log filter is able to found the error word in the record, then immediately the alarm is going to trigger. That's it. Next, so now here app level, this is the one which have created earlier with the alarms. Now this is the one which we have created with the help of the log filters. Now here, let me go echo sample data and to where and to this application log file. Right. So suppose action has been performed, like application, someone is trying to reach my application. So in the background log is generated. Right now my application log will be having a new record called sample data. So now here I will go to my alarms log groups, go to the application logs. See here, automatically your logs are going to push to your logs group. I am not pushing anything. In the background, the application generates the logs. Once the logs are generated in the log file, the data will be pushed to the your CloudWatch logs. Who? The agent. The job agent is going to do. So now I'm good. I don't have that alarm is not triggered because in this data I am not having any kind of error word in the records. Now I'm going to generate the error record. So now not traceable error 401. So now here my application now generated log with error record. Right. So now here if I refresh it, I got it. So now your alarm is going to trigger, right? Every minute, right? Every minute it is going to go and take the data. So now I just now have generated it. So in the minutes, in the span of 1 minute, your alarm is going to trigger. Perfect. See here, alarm is triggered in alarm state. Right? 1 minute of span, right? 1 minute. The 1 minute data is captured. Now in the 1 minute data, it can found it able to see the word called error in the records. Now the alarm is triggered. So now the action has to be performed. Right? What is the action? We are going to receive an email. See here, app error email. Perfect. And then, right, so you don't need to wait for months and months to see the issues with the application. Immediately, you can take the action on the application. How? With the help of this log streamings. Right, so here you can see, yeah, panel is having email, so this is the details, these are the details, like that. Right, guys? So likewise, we can do the log streaming with the help of the CloudWatch, with the help of the CloudWatch agent. Then we can set up the log filter, and on the log filters, you can create the alarm. Then that's it. You can leave it so that your applications are going to monitor by your CloudWatch and your agent, CloudWatch agent. Clear, guys? Then this is one of the important service, right? So then the next one is from the CloudWatch metrics. Metrics are nothing but, right? So whatever the rules are there on our services, right? So now if you want to see what kind of rules I can monitor, suppose if I go to the EC2, if I go to the instance metrics, right? So now here on the instance is EC2 git, that you can see, you can check these metrics actually. And here, yes, here. These are all the metrics. Networking, network out, disk reads, disk write files, disk read operations, disk write operations. So many things are there. Now these are all the EC2 levels. Now these are the instance private server status check well like that. So like that you can what right, the rules you can find from the metrics, right? So those metrics information you can find under the metrics actually. So now here, if you want to monitor any specific metric, then what you can do, like same, you can go to the particular metric, select, then from that you can create the alarms actually. Yeah. Just the thing is, right? So in the alarm section already we have seen, right? So the alarms are going to use the metrics only, right? Those metrics you can check it here. Here you can see create the alarm. So on this metric, if you want to create the alarm, simply can go and click on the create alarm. Right. So now here the metrics are nothing but the rules. What kind of rules we can monitor on the service level. So now here if I go to the metrics again, if I go to the all, so now here instance level metrics. Suppose if I want to set up the monitoring on the RTS level, database level. So if I go to the RTS, now here three database metrics across all the databases, database class, like different classifications here. So across all the databases, then you can see CPU. These are the database level metrics here. They're all there. Likewise, what now again here, only these metrics are not available, right? So lot of metrics you are going to see, but why you are going to say only the limited means these are the services as of now I have used it on this cloud. Suppose tomorrow I'm going to launch one more service, then those service metrics also I can see here. Likewise. So whatever the services you are working so far, you are working right now. What are services? Those services metrics you are going to see it here. Now see, just now we have worked with the logs. Now for the logs, you can see the log metrics. See here, account metrics and log group metrics. If I go to log group metrics, then application log, something like that. These can be monitored here. Likewise the metrics are. So now the next one is the events. Like right. So now here the CloudWatch can be used, right? So in multiple areas actually, right? The multiple areas means the monitoring, and second one is creation of dashboards so that you can go and see directly on the dashboard. You can set up a single place, and logs. The log stream can be done with the CloudWatch. Then the fourth one is cron jobs. You can set up the cron jobs by using the CloudWatch. That's what the events. That's what the events, right? So now here to understand the events, right? So now I want to set up the cron job. Cron job means what will happen at this particular point of time. Right? At the particular point of time, I want to take an action. Right? Suppose my business hours are Monday to Friday. So Monday to Friday, right? So now when the Friday business, like the business hours are over, means 10 o'clock, like morning 9 to 6 is the business hours. So after 6, after Friday, Then again your business will start Monday morning 9 o'clock. Now Friday to Monday, you don't require to run your servers unless, right? If I run my servers, then what will happen in the background? They're going to charge it. So now the Saturday, Sunday, no one is going to connect my servers. No one is going to use my servers. By that time, unnecessarily running the servers, nothing but you need to pay the amount. So in a month, 4 weeks, 4 weeks means 4 into 8 days. Unnecessarily, you are going to pay 8 days of the rent, right? Wait, right. So now here, what I can do every day, not the day, every Friday, once your business hours are completed, like after 6 o'clock, you guys can go to your servers and you guys can stop it. Again, every Monday morning 9 o'clock is going to start by your business 8:45 or 8:30. Start your server so that your application will be reachable to everyone. So that you can save the amount. 8 days amount can be saved. But it is a activity you have to be performed every week. Manual process. No, right? Sometimes I may forget. Right. So this activity should be automated. So automatically every Friday and like after 6 o'clock, after 6 p.m., your servers has to be stopped. And again, Monday morning 8:30, your servers has to be started. Right? This process should be automated. So now here, if you want to set up this automation, right, then like in our Linux, that cron job setup. In the cron job, I can set up like Friday 7 p.m. stop the servers, and Monday 8 a.m. start the servers. Stop and start. Fine, very good. So then here the action. What is the action here? Stop and start. What? The servers. So now who is going to do this action for me? Right. So who is going to stop the servers for me and who is going to start the servers for me? So there you can use one more service called Lambda functions. In our AWS, you can use the Lambda functions. So Lambda are nothing but serverless programming. Right. So usually when I want to trigger my script, suppose I have written a shell script. Now the shell script job is to install Apache, yum install Apache. Now where I'm going to run this command, right? I need a server. I need a server. On the server, I'm going to run this command, I'm install Apache. I want to install the Git, right? So for that, I need a server again to install the Apache, right? But the Lambda, right now to start the instances, I need to run the script called stop and start. Now to run the script, I require a server. Right? Again, you are going to use the server again. Now who is going to stop that server? Right? Understood, right? So now here the thing is when you want to perform an action like start the server, there are multiple ways you can do it. One is AWS CLI. You can use AWS CLI. Now with the help of the AWS CLI, you can stop and start the servers. We know very well, right? Configure it and use the CLI. But the thing is, if you want to run the AWS CLI, you require a server. Now I use the server to start the server. What about that particular server? Who is going to start the server? Right? Again, you have to go and do it manually. That's where the serverless programming came into picture. You don't require to take a server and run your commands. Automatically in the background, your AWS will go and run your code. That's what the Lambda function, serverless programming, serverless we are going to call it. You don't require any separate servers to execute the particular piece of code, right? So that is the difference. That is the difference, right? When you are going to the Lambda means when you don't want the servers to execute the code, there you can go with the Lambda function. Very, very effective. The Lambda functions are. Right? So now here the Lambda we are going to use to stop our servers. Now this Lambda we are going to you are going to configure the monitoring. Sorry, not the monitoring, cron job. That's it. Right. So now the combination is Lambda with the CloudWatch. This is the use case actually. Right. So now the Lambda, what is the Lambda here? Serverless program. When you want to execute your piece of code without any servers, then the Lambda is the one. This is the example. Right. So now let's go to the Lambda first. Then we'll come back to the event. So let me go to the Lambda. Right. So now here you can see that the same example. If you want to schedule the start and stop the servers, right? So now I don't require any separate server to execute the code to stop and start the servers. For that, what I'm going to do, I'm going to use the Lambda service of the cloud, called AWS Cloud. So now what I'm going to do, so I'm going to use a piece of code, That the piece of code is nothing but to stop your servers and to start your servers. The piece of code. Now the piece of code which language you are going to use. That is going to support .NET, is going to support Java, is going to support Python also. Like different languages are going to support by your Lambda. Now whatever the feasible for you, you can go with that the support language and you can write your code. Suppose I have taken the Python. Now I am going to write a Python code to stop or start my instances. Right. So now here again I require the access. I means who? The Lambda. Now the Lambda, what the Lambda is going to do? It is going to execute the code. What is the code here? Python code. What the Python code going to have to stop and start the servers? Now this Python code I want to execute to the Lambda. Now once the Python code executed, this code will go and stop your servers. Now here this Lambda is required the access of what? EC2 servers access. Right. So there what I'm going to do, right? So I'm going to give a role. I'm going to write a role, right? See guys, IAM roles are going to play a vital role here, right? Many areas. Just now I have seen the CloudWatch groups. Now here, likewise the roles are going to play a vital role in our AWS actually. Whenever you require a access between the services, you don't require a user level access. Simply create a role. Like now here, this Lambda will be trying to access the servers, AWS servers like AWS EC2 service. Now for that, this guy requires the access. This access we are going to provide to the IAM. That's it. That is the setup. Now go and try to implement it. So now go to the Lambda and create a function. So right, so I will go to my AWS service, then I will search for Lambda. Right. So as of now, I don't have any Lambda functions. Now I'm going to create a function. That function is but you are going to have a piece of code. The piece of code you are going to execute with the help of this Lambda service. So now from the scratch, I don't have any kind of predefined code. So I'm going to write from the scratch. Blueprints, right? So you have some predefined code is available in the form of blueprint. See, syslog to JSON, batch get job, S3 get object Python, like that. You are going to have a sample code, a blueprints are available so that you can go to the code and you can modify it according to your requirement. This is one thing. Or if you have the code is available, some repositories. Now you can take the code from the particular repository, from the serverless app repository. Right. We don't have anything as of now, so I'm going to use from the scratch. So I'm going to write it. So now here, function name stop EC2 instance. This is the function name I am going to provide. Right. So as I said, our Lambda is going to support different languages. Right. You can write the code in different languages. See here, .NET, Go, Java, Python, Ruby, like that. So now I'm going to use the Python language. Right. So now here permissions. Right. Right. Your Lambda require the permissions to connect with your EC2 service. So now if you have already the role is available, then you can choose it. Right. So or you are going to ask your Lambda to create a new role with the permissions. Or if you have the role, or create a new role from the AWS policy templates. That you can use the policy templates, then you can create a role. Right. So I'm going to ask my Lambda to create a new role. So that it will take the required permissions. Then create function. Here I have taken a role actually. The policy I have taken, the policy I'm going to configure. But here right now, this is right. Suppose if the role whatever I'm creating here, I ask you to take the role. If the role is not working, then we'll use this one. This role we are going to use. Fine. So now here the thing is, select the create custom role with the limited permission, then go to IAM role and create the policy. This is what actually we need to do. Okay. So now here I am not using that one. I ask you to create a role, not the custom role. Create a new role with the permissions. Let's see if it is going to work well and good. Otherwise, we'll create a role with this template. Right. So now here I will write. So now here go. Now I need to write the code. I need to write the code to stop the instances. So for that, here you can see stop the instance function. If I scroll down here, you can see lambda function code. Right. Now write the code here. Right. So now here the code to stop the instance I have given guys at the end of the PPT. This is the code. Now take the code here and go to your right. So here the thing is I require my instance ID. Running instances. Suppose I want to stop this instance. So this is the ID. Stop instances and scroll down. So this is the code item I'm having, and here this is the instance ID. Right, so here ES2 is the region. Perfect. I'm in the same region. And suppose I want to stop this instance. Okay. So now here, once this part is done, click on deploy. Okay, so now here you can test it. You can test the code. Click on test. So now here create a new test event. So now here the some name. If your event means if your lambda function is having input, if you need to pass input, you can pass input here. So as of now, I don't have any inputs, so I'm going to leave it as this. Then scroll down, create event name, stop EC2, and create. Now click on test. So now we're going to execute the code. Then here it is going to give syntax errors. Yes is two instances, invalid syntax, lambda function keyword, line 2. Line 2 is having some syntax issue. Okay. So here, let me bring it down. Both are in the same region, right? So now here deploy and go here and test it again. Execution failure. So now here test it again. Now line 7. Line 7, you have an issue. This is the okay, this is a print message. So let me remove this print message as of now. And click on test it again. Deploy and test. Now trying to execute and see. See here, now you are not authorized to perform this operation. Okay, now the code is working fine, but the problem is authorization. The lambda is not able to authorize to perform this operation because right. So that's what. So when I'm going to create the lambda function, by that time it's asking for what called the role. So now there I ask you to take the uh, create a custom role for me, not the custom, create a role for me actually. So right, so that is the reason the role got created but with limited functions. So now what I'm going to do, let me delete it. Let's do the exercise from the scratch. Create function, and the function name is stop EC2 instance. Then I'm going to use the Python code, then the role part. Go to the role. Now here create a new role from the custom policies. Right here I record the policy again, right? So but here the policy is our own policy actually. So let's stop it here. First go to the roles part and create a policy here. Then this is the one actually. Yeah, so here select the role which you have created the step and choose the policy and paste the below code. Right, so here one thing will be create a policy here, and with the policy you can create the role. Then the role can be selected, or create a policy that you can use the other option, create a role with the custom policy. Now in the custom policy you can modify this code. Anything is fine. So now what I'm going to do, I'm going to create a role here with this policy. So I will go to my AWS. So then from that I'm going to choose the IAM. So now this IAM, I'm going to create a policy first. Policies. So now here create the policy and JSON. So in the JSON, I'm going to add this code. So then, so this code is nothing but here, right? You are going to send the logs to the logs group. And here in the second block, we are going to take an action and start and stop on the instances. This is the policy actually we have written. Right. So logs will be sent to the log group, AWS CloudWatch logs, and here the action will be start and stop. Review and policy, and here the policy name is EC2 start or stop. So now here this policy I am going to create. Right. Once the policy is created, then what I'm going to do, I'm going to create a role by using the policy. Go to the roles and create a role now. Create a role. Right. So here, who is going to take an action? Not the EC2, right? The lambda is going to call this role. Now choose the lambda permissions. Now here you need to attach the EC2 start and stop. Right. So now tags review, and my role name is EC2 start and stop. Here the role. Right. So now if you guys observe, right. So now here this role is attached to the lambda, not to the EC2, right? Because this lambda is going to take an action. Right. That's what the point which you need to focus. So now here the service is not going to be the EC2. The service is going to use by lambda now. Which service? This EC2 role. Now go to the lambda. Now here use an existing role. Then here you can choose our EC2 start and stop. Perfect. Now create a function. Python 3.8 blah blah. Right. So now create a function. So now here take the code. Now this guy should be on the next line. Instances. Now this is the ID of my what call my instance. So now let me take this code, copy. Now go to the lambda, right? So now scroll down here and here paste the code. Deploy and test. Right, so stop instance. Then create. Now you can test it. Right, so now here the test is going to execute. Now see, succeeded. Right, now I got the access. I got the access. Okay, so now let's go to the EC2. Public server is stopped now. Right, right, because right, not the because who is going to take care of this action? My lambda function has taken care of this action. So now here I will go to the functions again. Now this is the stop instance. I'm going to create one more function. Start EC2 instance. Right. So again the same code I'm going to use. Python. Right. Required authentication. The permissions are required. So I will go to the permission part. Right. In the policy I have given both the actions start and stop. Right. I can use the same policy, the same role. The same policy which is attached to the role. Now create a function. Now scroll down here, add the code. Now this code here I'm going to change here the function name I'm going to change. That's it. From the stop to start. Rest of the code will be the remain same, no changes. So copy. So remove the code, deploy. Then create a test event. Start instance. Now create it. Now test it. Succeeded. Perfect. Now go here. Refresh. See here, it is pending. Now I have the code. What code? Serverless code. Not the right. I don't require any servers to execute my code. Nothing but the lambda. Now I have the code to start and stop my instances. Two functions are ready. Right. But here to stop the instances, I should not go and select and go to the action, then test it. Right. I don't want to do this. It should be an automation. Right. So for to do the automation, there we are going to use what? Our CloudWatch events. Right. So now here, once the code is ready with the functions, then I will go to the CloudWatch again. If you have multiple instances, give the comma here, comma, and in between the codes, the instance, the second one. Likewise, you can give the commas and you can add the multiple instances. If I go to the log loops now, right? So here, see here, start instance, stop instance. The logs are automatically exporting into my CloudWatch. How? The policy, right? So the policy, whatever the policy we have created, in the policy we have mentioned that, right? So go to the log groups also. Right, create the log group. It's going to create the log stream, log events also, right? So that is the reason your with this policy, the logs group also created. So here is ranked access. So now here the one which I am going to focus on is events triggering automatically. These jobs has to be triggered. The jobs means the lambda functions. The lambda functions has to be triggered automatically. So then what I'm going to do here is create a CloudWatch event that triggers your lambda function to start to stop instances. Like something so and so time. Right. So now go to the CloudWatch events, then create a rule. So now here I go to the CloudWatch events, then here I am going to go to the rules. Now create a rule. Right. So here event pattern and schedule is there. Right. Event source and target. Two sections are there. In the first section you're going to see the source. In the second section you're going to see the targets. Now event pattern is nothing but right. So what you want to do? I want to what is called I want to connect to the auto scaling. Right. Launch instance launch and terminate. Right. So a specific event you can set up it here. Specific events successful like that. So the specific patterns you can set up it here. So now here otherwise what I can do that you can set up the batch, you can set up so many things you can do it here. So now the second one is the schedule actually. That's what the cron job. Now the cron job right fixed rate of 5 minutes. Every 5 minutes the target will be triggered. This is what. Or you can choose hours and days also continuously. Fixed schedule. But otherwise, if you have to have a cron expression, and this cron expression is somewhat a little difference you are going to see here. So from the AWS side, so now if you want to work with the cron expression from the AWS side, this is the document you can follow. Schedule expression tools. Wildcards can be used like the hours and same, just a small variance you are going to see the wildcards actually. Those we are not going to see and the rest of the parts will be the same. So they will provide some examples here to set up the rules and agents. Right? So now here this is the like you can go to documentation to set up the CloudWatch cron jobs on the CloudWatch side. So now here, so I will follow the pattern 430 pattern whatever they mentioned here. So 011 star question mark star. So 011 question mark star Monday to Friday. Monday to Friday. See here. When I set up this one means Monday 29 September 2020 11 o'clock morning 11 o'clock this event is going to trigger 29 11 o'clock 30th likewise every day 11 o'clock this event is going to trigger until Monday to Friday. Right. So this is what the cron expression. Okay, fine. So now here suppose 11 o'clock I want to start 7 p.m. 7 p.m. means 12 plus 90 7 p.m. Now 7 p.m. this event is going to trigger. So what the action has to be performed here? So that's what the target. So click on the add target. So then here function you are going to see and here stop the EC2 instance. That's it. Right. Then that's it. Leave it. So that this event every Monday to Friday 7 p.m. it is going to start. Suppose it should be taken action on only the Friday. Then what I'm going to do? Right. So now second, 9, 6, 10, right? Because I don't want to stop the instance every day. I want to stop the instance after the Friday. Then again, I want to start the instance Monday morning. Right. So for that 7 p.m. and every Friday, it is going to stop the instance. Configure it. Create the rule. Stop instance. Right. So likewise, we are going to create one more rule. We are going to set up it so that automatically Friday, this rule is going to trigger, and this rule, right, every Friday is going to trigger. It is going to call the lambda function called stop instance. Now the lambda function, it is not required any server to execute the code. In the background, they are going to use the containers or the virtual machines in the background of AWS. They are going to trigger this code on those containers. Then your code will be executed. Then finally, it is going to stop your instances. Serverless programming. Right. Likewise, we are going to create one more rule to start the instance on Monday, every Monday morning 8 a.m. or 8:30 a.m. like that. Right. So now here if you want to understand, if you want to work with the lambda functions, right? So if you want to work with the lambda functions, then this lambda will be using Boto functions, Botos. Right. So now here, if you want to work with the lambda, right? If you want to work with the EC2 service details, right? Not only EC2 or AWS. Right. Tomorrow I want to work with some CloudWatch. So now, if I want to work with the CloudWatch means I want to write a lambda code for the CloudWatch, something that I want to perform some actions on the CloudWatch. Then what is the code? How can I write the code? Right. So if you guys observe here, so to stop the instances, I have used a function called start instances. To stop, I have used a function called stop instances. I need to understand these functions. So for that, they have given the documentation, guys. So you guys can go to the documentation of the Boto functions. So now we can use these Boto functions to write your lambda code. So I have given the link. So when you have the time, right, just go through these Boto functions. So now these Boto functions can be utilized in our lambda. See, so many services will go. This is the EC2. So if you want to work with any service, right? So then after that we are going to see these are the functions actually. So now here out of all the functions I have taken the start and stop. Instance. If I go to instance level, the search will be start instances. So this is the function I have used. Then you can see the code, how to use this function, all the parameters. So like this. Right. So now this is the useful documentation. If you want to work with the lambda side, so there we are going to use the Boto functions. The Boto functions you can find from the boto3.msg.com in the site documentation. You will get everything here. Right, guys? So this is about our lambda and the auto triggering of the jobs with the help of CloudWatch events, the cron expressions. Right. So then the last service, the last service is nothing but our what is called Route 53. Right. So if you want to work with the Route 53, means the Route 53 is nothing but so whatever the applications we are launching on the server, right? So the applications are nothing but what is called my web servers. Right. So the web servers are going to utilize to launch your application like Flipkart.com, Amazon.com, or BrightlyPartners.com or some XYZ. Right. So now here we are going to use the domain names, not the IPs. But as of now, we have used the IPs to access our applications, right? Because we don't have any domain names. We don't have any domain names to access our applications. So now here, when you want to work with your applications with the help of the domain name, and there we have a service in our AWS. We have a service called Route 53. If you want to work with the domain names, right? So once again, guys, I will be back. Yeah. So here my application I want to map with the domain. So what I'm going to do here is, so right now Apache is installed here, right? Perfect. So now on the Apache, I'm going to deploy the application. So let me take, this disconnect. Maybe I have stopped the server. Let me go and see. When I stop the server, it got disconnected. Yeah, public server is running fine. So let's see. See, not reachable. 401 is the record actually, and when the server is not reachable. Public server. Okay. The IP is got changed. That is the reason I am not able to connect it, right? So let me change the IP because I stop and start the server, right? So now I'm going to connect. Right. So let me go to my SCP and let me try to connect the server is type and user advanced and authentication, right? PPK. So this is the PPK. Connect, login. Yes. Done. So I will go to the application, right? The sample application. I will go to my sample application. Then the application I'm going to, what I say, I'm going to copy into my server. So right away, so this is the one I'm going to copy into my server. Yes, okay. I will try to access the server. Sudo admin, service distributed status. It is not running. Start status. Try to access. Okay. So now here, let me go to the WinSCP. It is copied. So now what I'm going to do, I will copy the code, right? So cd home ec2 user. Here I have the folder called big city. This content I am going to copy where into my deployment location of the web server called Apache, where www.html. Right. Now try to access it. Now it has to launch my application. Right. So now my application called Big City is launched. Perfect. So now here, if I am going to access my application with the help of IP. Right. But in the real time, in the real world, we are not going to use the IPs to access applications. There we are going to use the domain names. Right. So the thing is here, when you want to use the domain names, now you have to purchase the domain names. The domain names are not going to be available as a free. You have to purchase the domain names. Now, once you purchase the domain name, then you can map your domain names to your servers so that your domain name can be utilized to access the application. That is what the story for the domain names. Right. So now we require a domain name to see that use case. Now I'm not going to purchase it, right? So domain names will be like $10, $12 for like they are going to charge like for the maintenance every year or 6 months. I need to pay some amount of money to maintain my domains actually, right? So now here the domains you can purchase from the third party vendors called GoDaddy. So those guys will provide the domain names for us actually. So if I go to the site GoDaddy, right, $149 for .in, right? Uh, Shankar.in. I think it is blocked. Right. Okay, my laptop, right, is office laptop. They are blocking this site. Okay, fine. So you can purchase. See here, you can purchase the domain names from the GoDaddy. Like they are going to give some price. .coms you can get with the $499. .in you can get with the for $149. Like likewise, we can purchase the domain names. So now here to see the use case, now I am not going to go with the GoDaddy or some XYZ because I need to pay some amount of money. So we have a site called Freenum. Freenum is a site where you can get the free domains from this site. You can get the free domains from this site, right? So now here the thing is you required to have a account on the freenum.com. Right. Suppose here before logging to the account, so suppose I want to see Shankar DevOps. So here I am looking for this domain Shankar DevOps. Now see you can get this domains not from the shankardev.com or shankardev.in. So you can get the domain name free .tk, .ml, .ga, .cf. Like these extensions I can get on the free basis. Right. So now here let me I want like okay fine. So just to see the use case with the domain name I want to access the application. That's whatever it may be. So I will use the shankardev.tk because I'm going to get it. So now to get it you require the account. So I'm going to create an account here, right? So like our what is called GitHub, how you create an account on the GitHub, the same way you can create an account here. Otherwise, you can use your Google or Facebook to log into this account. Okay, already I have an account. You can use anything. So here I'm going to use. You can see now I have logged into this freedom.com site with my domain with sorry not the domain with my account name called Shankar. So now if I go to the services, there I can see my domains is the section. If I go to the my domains, there you can see whatever the domains you have taken so far. I have taken this domain on the 7th month, shankar-devops.tk. Yeah. So likewise, right? So now here is the free. Right? So now here again, I want to take one more new domain, register new domain. Let me go to the register new domain. And here, what I am going to do, I am going to create a new domain here. I want to register a new domain, right? So Shankar DevOps. So now this is the site I am going to launch my application. Right, Shankar.tk is available. So get it now. Select. Now it's going to check out. Selected. Then scroll down. Here you can see if you want to take the .com, $8. Right, the cost. If you want to take .net, this is the price actually. If you want to go with the others. So now here finally go here and check out. Right. So now once the item is checked out into your cart, so now click on the continuously here. Right. So you can use 12 months as a free. Then after that you need to pay the charge. Right. So here I don't want to take 3 months. I just I want to see how the domains are going to work. 1 month. Continue. Let's then complete the order. I have accepted it and complete. Thank you for your using the confirmation shortly. Now services, now go to my domains. Now I can see Shankar of the TK is available. It is active. It is active, right? So today's date I have created it. Sorry, not the today's date. Sorry, today's date I have created. It is going to expire, right? So it's okay. So now, once the domain is ready, right? What is the domain here? Shankar of the TK. Now this domain I'm going to use to access my application, not the IP. So now what I need to do, I need to map that domain name with the server, right? So to map the domain name to the server, then in our AWS there is a service called Route 53, domain names registration, scalable DNS, and domain name registrations, right? So now here the AWS itself is going to provide the domain names. You don't require to go to any freename.com or any GoDaddy. You can purchase the domains from the AWS itself. That's what the DNS management, sorry, domain registration. From here you can register your domains. You can purchase the domains from here. See .com, $12 like this. Now you can purchase it here, right? You don't need to go to any separate third party. Suppose already you have purchased, like suppose right now I have purchased my domain name from the freename.com. So now I don't want to register it, right? So now I'm going to go to the DNS management. I want to map it, right? So create the hosted zone, right? So here let me go and open the site. So the this is what the domain story actually, right? So here whenever you have send the traffic request to the domain name example.com, it will go to the route 53. From the route 53, this name will be translated with the IP, and the DNS resolver, domain name resolver will convert your domain name to the IP. Then the IP will be traveled to the end user. Like simple architecture. So now here what I'm going to do, I will go to the route 43. Then here I am going to create the DNS management. Then I'm going to create a hosted zone here. So DNS management. So now here I am the hosted zone, right? From the route 53, get started, right? Register domain, right? I don't want to register it, right? Because I already have the I have the domain name. Create a hosted zone. Get started. Right. So here DNS management and here created hosted zone. So now here once the created hosted zone here domain name is my domain name is Shankar DevOps. Go here once. Copy and here paste it. Right. So this is the domain name. Then here, right, it is a public hosted zone or private hosted zone, right? It is a public, right? People can reach my server. Then here, description you can pass it and choose the public hosted zone. Then go here and click on create hosted zone. Right. So now here, my record got created. Right. So this actually the view got changed. Actually, they have created some new view. The older one will be something different actually. Okay. So now here you can see one name server is created, Shankar.tk, and one SOA record is created for the same actually. So these two records are going to use by your these two records are going to use by our what is called resolver, DNS resolver. The records are going to use to convert your name server, the domain name into the IP section. Right. So now here, once that is created, the record got created. I mean to say, what is called hosted zone is created. Then we are going to create. This is what I have created. Usual path TK, and this is the public hosted zone we have selected. We have created. Then after that, what I need to do, we need to create a records actually. So the records are nothing but you have to map the domain name to the server. By default, you are going to get the name server and as well as SOA records. These are the two default records you are going to get. Two records you are going to get for your site for the hosted zone actually. So now I require to create a record. Now the record is nothing but the domain name mapping. The domain name mapping. So let me show you. So this is the what is called blog, right? Yes, so there they have explained each and every step. So I have given the same. So now here, so let me go, 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 let me go here, go here. Yes, this is the one. Right. So now the mapping. The last part is the mapping, which I need to do. Right. What the mapping you need to do? Whatever the domain you have purchased or whatever the domain you have taken, that domain has to be mapped with our Route 53. So for that, what I need to do? Still they are loading. Right, NS and SOA records are created actually. Right. So now I am going to create two more records. So the records are nothing but for my domain mapping. So the domain mapping I am going to do. Right. So let me go to my Route 53 and I am going to click on create a record. Right. So here you are going to see simple routing, weighted routing, geolocation routing, multi-value answer, failover, latency. Right. They have changed every, right. The view got changed actually. Okay. Let's take the simple routing. Just the request has to go to server. So next, and define the simple record, and here shankar.tk, choose endpoint, choose endpoint here, IP address or any value, alias and the record, alias IP gateway, alias. The endpoint should be in the server actually. That's what I'm looking for. IP address or yes, this is the one. So now here shankar.dev.tk. If someone is entered something like the shankar.dev.tk, then the request has to route it to IP address. Now what is the IP address here? So my IP address will be this is the one. I want to connect to this server. Right, then leave it the rest of the define the simple record. And I'm going to create one more record. Right, so now here see NSSOA, then I should see our record also here. Wait, it's gone. Yes, shankar.yeah, right? So this is pointing to where my address. Now create one more record, simple routing. Next, now I'm going to create a different simple record. Now here some people are trying to give www.shankar.tk. So at that time also I want to connect to my IP address, and this is the IP address. Define the simple record and create the records. That's, so now apart from the two records which I got, the default NS and SOA records, then we have created two more records for www.shankar.dev.tk, which is going to route to this particular IP, the server, and also one more record to only shankar.dev.tk, and also is going to route to the same server. So now this is the one part from the Route 53. Now the second part, whatever the NS records we got, right? Right. So this records you have to you have to capture, you have to given to our what is called domain name. So wherever the domain name we have created, the domain name has to map with this NS records actually, NS values. These things has to be mapped with actually. So now here, what I need to do, we have to take these data, the values of the NS record. Let's at the end, dots are not required. Remove the dots. So now these are the 4 values which we got with the name server. So now these name server data has to be mapped with your domain name. So where the domain name present? In my freenom.com. Here I have purchased my domain name. Right. So now go to your domain name and go to the manage domain name and click on the settings, manage domain name. I want to say manage domain name. Then here you can see 4 different tabs. Go to the management tools and here you can see name servers. Click on the name servers. So here I don't want to go with the default name servers, whatever the name servers are provided by the freenom.com, because my name server is right now my Route 53. This name server details I need to provide here. So now here I will go to the freenom.com and here use custom, my own name servers. So now whatever the values of the name servers are there, take the values, copy and provide the values here. One, and take the second one, copy, second one, and take the third one, copy, third one, and fourth one. Perfect. Now for the name server values I have given here, then click on change name servers. Right now here our domain is mapped with our name server. What name server? Whatever the name server I have created on the Route 53 of AWS. Now the linking has been established between my domain name and the name server. Now try to access it. Service, my domains. If I click on here, it will try to connect to the Shankar.tk. So perfect. Let's see here. So now here Shankar.tk. I am not using any IP address. Right? We are going to use the domain name. Right? Even though if I give www.shankardevops.tk, still it will be routed to my application like that. If I don't give because I have created 2 records. One is without www, the second one is www like that. Right? So this is how we are going to map our domain names to our web server so that people will try to reach our servers, nothing but our application with the help of domain. Right? That's what our service called Route 53. So now the Route 53 not only just to route the traffic to your servers, it is going to do the other things also. Right? So the other things are nothing but if I go to create record, right? So simple routing. Take the request, route it. Weighted routing. Right. So now here you can route traffic, you can route the traffic into your targets. Right. So now this is nothing but right. So usually people ask the entry question. Like if you guys remember load balancer, what the load balancer will do? Your load balancer will route the traffic to your servers. Where? On your region. Your services are belongs to the region. Now if I launch my load balancer in a Ohio region, US is 2, then the load balancer belongs to Ohio region only, not to Asia Pacific or not to Mumbai. But to maintain the high availability, if the Ohio region is gone, then your application will be gone. Right. So now to maintain the high availability, I have to deploy my application into some other region called suppose Mumbai region. So that if the Ohio is gone, still I can have the Mumbai region, like high availability stuff. So but here Mumbai is a different region and Ohio is a different region. So how we are going to send the traffic to Mumbai and Ohio? That's the problem because load balancer belongs to the region level. You cannot send a request from the Mumbai region. There we are going to create two load balancers. One is Ohio region load balancer and second one is the Mumbai region load balancer. So now we are going to create a route 53. Now the route 53 will be send the traffic to the Ohio load balancer and the Mumbai load balancer. Right. So now when you want to split the traffic to the different regions, the load balancer will not be handled at different regions. The route 53 will be taken care here. Now the route 53 we can be send the traffic to different regions. Now again, the application majority of the application is what your Ohio, because your application is more preferable to the Ohio people, the US people. But safer side, I am taking the Mumbai because high availability. So now what I am going to do, I am going to send most of the traffic, 70% of the traffic to Ohio, 30% of the traffic to Mumbai. This is the safest one, just for my safe side. Likewise, you can create a records, weighted records, so that if you want to send the traffic into two different regions with the help of the Route 53. So here click on next. So now here some name. Now here you can define that actually. Route traffic, simple mail server, PTR, SPR, load balance. Actually, right now, load balancer, I don't create the load balancer actually. If I create the load balancer, the load balancer will be listed up here. As of now, we don't have any load balancer. That is the reason we are not seeing the load balancer record here. Once you create the load balancer, that will be listed here. Then we can choose the load balancer here, like that. So like that, we have a weighted and geographical location wise. You can send the traffic, China, India, like that. Likewise, latency, right? So now here, Ohio, like your servers are near to Ohio, then your servers are like far to Mumbai. So now here, whatever the servers are near, those servers we can route the traffic based on the nearest one to you. The latency can be handled. Failover, if something is failed, one region is failed, then immediately I want to route the traffic. That's for the failover. Multi-value servers, like nothing but right. So right, again is the kind of geolocation. Right. So just go through these different types of routing policies, right? So the documentation, go to the documentation, you will come to know like this is one kind of interpretation for that actually. Sometimes people ask, I want to send a good amount of traffic to one region and I want to send very less weighted you can use, or you can use the latency weighted. I want to send only the traffic to the China people, not to the India, and I want to send only to India, not to China, geolocation wise or multi-value. Likewise, we can use the Route 53 to send the request the where the servers are resides, where the servers are, where the application deployed, like that. So we have used the simple routing. Take the request and send it, route it. So Route 53 is going to play different roles, very very important roles in our application side to handle application to handle routing traffic also, like this. Right, yes. So this is about our AWS man. Sorry, AWS guys. So important services. Many services will be there based on the requirement, based on the use cases. We'll go and we'll explore it. Okay. So tomorrow I am going to start Terraform. Okay. So we'll see the Terraform, then we'll see the other tools actually, the scripting and the monitoring in IDOs. Okay. So that we can wind up actually. So that tomorrow I'm going to start the what is called Terraform. So please practice it, guys. So these services are important actually for the interview sake, for the real time sake. The rest of the services, as part of the requirement of the project requirement, we'll go and use it. So tomorrow I will show you two more services. Recently, that AWS is launched. So most useful services those are actually. So just I will give you overview so that you can come to like these services. What are the services purpose? Later on you can practice it or you can leave it just for the understanding. But those are the two useful services they have launched actually. So tomorrow we'll discuss those two services. Then we'll go to the Terraform. Right, guys? So this questions and clarifications we'll discuss tomorrow. I have to go somewhere, so we'll meet you tomorrow at the same time. Thank you.
Thank you.
Yeah, thank you.